Welcome to Azure Backend for Gaming. My name is Steve Meyer, and my coworker here.
I'm Michael Cummings.
And we both work for Microsoft, and we're going to have quite a bit of game experience in teaching and developing games. And so we want to share some of our experiences with you and some of the topics that we've utilized for using cloud computing. Okay, so first of all, with a little introduction, my name is Steve Meyer. I'm a senior technical evangelist for Microsoft. I focus on Windows, Windows Phone, Azure, and gaming. I also am an adjunct instructor at the Rochester Institute of Technology in the Interactive Gaming and Media Department. It is the number 7th game programming college in the US, and I always make sure to point that out because Michael, who lives in Boston, has actually done a lot of things with MIT, and they're 9th in the country. So I like to make sure to, especially when I talk in Boston, I make sure to point out that, yeah, the school I help teach at and everything else they're doing quite well.
Yeah, well, we're beating you in hockey, so we got you there.
Mr.
Rochester and Buffalo.
Just a little bit, yeah, but that's okay.
Yeah.
I also done quite a few mobile apps because I actually created a user community called App Rochester 5 years ago to where it helped teaches people how to make mobile apps, games, and things of that nature.
So I'm Michael Cummings. I'm a software engineer in Microsoft. I work on the Intune team, working on the Android client. So my day job right now is working with a lot of Java, and so it's not as exciting as the stuff I work on games. So prior to joining Microsoft, I was an XNA MVP for 5 years, from 2008 to 2013. As a side project, just in my spare time, because I'm weird this way, I maintain an open source rendering engine called Axiom. And before I took that project over, I was working with a team around the world on a MMO called PlaneShift. And that's based in Italy at planeshift.it. And I added some really cool features into that system. And it's still going today, which is really cool. I also, as part of my MVP, I had an XNA user group and got into all this speaking and stuff like Steve does as well.
And so we'll do many different speaking engagements. Recently, I was at a PAX East conference in Boston, and that's the Penny Arcade Expo for independent game makers. And I gave a talk on game making for high school students, myself, one of our coworkers, and my son, my younger son, Brian, who was, interesting enough, is 16 years old, talking in front of 250 people, but today's actually his birthday while we're recording this. And so,
happy birthday, Brian.
Happy birthday, Brian. So he's now 17 years old. But to actually have a 17-year-old in front of a stage, on stage for 250 people.
Right.
And that was the first time he ever talked to that many people.
And he didn't seem all that nervous.
I know he was. But actually the other evangelist from Boston, Gavin, he kind of was a little more nervous, and he sped through his talk. And so we kind of had to spend more time. I had to spend more time, and Brian had to spend more time on his demos. But it was a pretty interesting way of doing it. And I love to be able to go to conferences and talk those kinds of things.
Which brings us to today, right?
Absolutely. And so today we're going to talk about using Azure as the back end for your gaming. We're going to start with this first session on networking basics, and then move over to cloud basics and the Azure resources that you can use for online games. Then we're going to talk about our client-server architectures and also peer-to-peer and some of the games that we've played over the years and how we can actually set up those architectures. After lunch, after our meal break, we're going to be talking about authentication and how important that can be to your game to keep things private. And after authentication, we're going to have some very exciting topics of using Unity as a client, Construct 2, which is an HTML, JavaScript tool to make games. And then also we're going to talk about a case study, Age of Ascent. Age of Ascent is an online multiplayer game where they do a space battle. And the nice thing is that the people that are joining us live today, we're going to be able to play it live and play against each other. And I think I'm going to beat Michael on all of his things. I've been practicing on it, and I think I'm just going to wipe him out of the sky on that one.
I think you better up your game a little bit there. I mean, that's a throwdown. And
I think I might be able to do it, but we'll have to see when it comes down to it. And then the last topic is talking about a Photon server, which is a pre-made server engine that you can utilize in your own game making. So we're targeting people that make applications and games, but I mean, it could be a student, someone that's interested in games as well. Someone who might be familiar with Visual Studio, because we're going to talk and show a lot of Visual Studio. Michael and I as developers love living in Visual Studio all day long.
Absolutely.
And of course, using free tools such as Unity and Construct 2. Now, they're free to use and to play with and get set up. And at some level, they make you pay royalties or fees or buy licenses. And each of the game systems is different. Unity just changed theirs recently to say, once you're making over $100,000, then you need to start paying for it. So each one is a little different in what they want for pricing. And we want you to join the MVA community. There's over 2 million registered users. We have things for IT pros, developers. There are topics on Unity, Construct 2. There are ones on almost every aspect of it, from learning C#, learning JavaScript, even learning how to do things like making websites. And you, of course, get a 50-point MVA bonus for this event. Now, it expires in May, but if you go ahead and add that in, and then you'll be able to get some credits and show that you are a little bit higher than your friends on the MVAs.
Go game. Competition.
Gamification. It's a wonderful thing. All right, so we're going to start off with a lot of networking basics and start with a lot of things that a lot of this is going to be a lot of review. If you've taken a networking course, if you've done a lot of like a raw networking class itself, that's what this information is all about. So we're going to start off with talk about some of the networking standards. And we're just going to go over a couple of them, then talk about TCP and UDP, and finish up with WebSockets. So starting with networking standards, we're going to start off talking about the Open System Interconnection, the OSI model for networking. It is one that's been around for a long time, and it's really helped to divide up and set up how modern networking is done today.
And why are standards necessary, Steve?
Well, standards are necessary because you have things like the HTML5 standard, which before it was a standard, every browser was doing things differently. They would implement things in a different manner, how they thought it should be implemented and what they thought the best way was. And the problem with that is then when you're making a website or making a game that's going to utilize that, you have to then code against every separate browser's way of doing things. And having a standard and an industry-wide standard makes it much easier for doing it.
So with something like the OSI standard, we have the ability now to make disparate systems, whether it's Linux or Windows or Mac or whatever else we have come across. They have a unified way of being able to talk to each other now, right?
Absolutely. Just like we can run web servers on any platform and any browser can be able to get to them, the same way with our games that we're going to be developing and looking at today too.
Excellent. More players. We like that.
We love more players. More people for us to beat.
Yes.
No. Okay. Now, there's another protocol which is also called the TCP/IP model, and it was developed by the DoD, Department of Defense. And it was set up because obviously we want to have a very reliable communication. And this is actually comparing the OSI model to the TCP model. The OSI model has 7 layers from application all the way down to the physical layer. And all of those very much correspond to ones in the TCP model: the application, the host-to-host, the internet, and the network access.
So when the DoD developed the TCP/IP model, they built on top of the OSI model so that everything worked together, right?
Absolutely.
There we go.
There's some things that the military will do correctly and make sure they get right.
No, I'm not going to say anything about the military.
Okay, we won't say too much about the military. But they to make sure that their data is very good and it's very reliable, they want to be able to utilize an existing standard for it.
All right, so how does this apply to gaming? Where do we take this? I mean, so we've got application, point-to-point internet, and network access. Where do we go to? How are our games going to leverage this stuff?
Well, typically what we're going to do is we're going to start off with talking about TCP and UDP. And that's in the middle of that communication, that transport layer. Now, TCP and UDP are different protocols for being able to, TCP keeps a connection to the server, it keeps packets in order, and it acknowledges when you send it data. Now, UDP is a little different though. It doesn't have the same thing. Packets can be out of order, but it does have lower overhead. Things can go faster. And it is what's considered by many a connectionless. It's more of a fire and forget. I sent my data out. If you got it, you got it. You didn't, you didn't.
So TCP could be used for services that require the data to actually get to the client or to the server, whereas UDP we can use in situations where we don't necessarily have to get that data, that it's repeatable data.
Well, and also if it's something that's in a very particular order. If you were doing your movement in your game in relative coordinates, saying, hey, they move 10 pixels forward and 10 pixels that way, left, and everything is relative, then the order really kind of matters. Otherwise, it'll look like people are jumping through walls because that's not what's happening.
So hint, don't do your movement in relative coordinates. Use absolute, and then you don't have to worry about order.
That would actually be very handy.
Yes.
And the thing is, if you do it with an absolute coordinate and you use something like UDP, which wasn't guaranteed to get there, well, hey, the next coordinate did get there, so we missed one, it's okay. We can just skip it.
Sure.
Now, part of actually setting up of these protocols is actually the header for the data. And the TCP and UDP headers are slightly different. And when we look at it, the TCP does need to keep things like sequence number so we can actually say what order it's in. And if we accidentally forgot and didn't get one. So we could actually request back to the server, I'm missing packet number 5. Well, then it can resend it to us. Whereas if we look at the UDP, we still have our destinations and our length and checksum, but that's it. There's no way of saying, hey, resend this packet number. That's not built into our data.
So what I get from this is that the TCP packet format is a little heftier. So it's, in order to get all that reliability into there, so there's less room for the amount of data that you want to send. I mean, a little bit, but there's a little bit less room in there, where UDP, because the packet header is a little smaller, we got a little bit more space for sending data through, which means that we can have, faster throughput with UDP over TCP, but with a sacrifice of reliability.
Absolutely. Now, now things like you wouldn't want to send, hey, I'm doing a purchase of something in a store or something like that over UDP because it might not get there. But you would want to have that to be under TCP.
Yeah, because I'd be waiting for that delivery, and if it didn't come, I'd be upset.
So, and the other thing is that when we start looking at how we're doing the handshaking and how all of these things connect, the UDP and TCP are dramatically different. So as I said, UDP is more fire and forget. So we're going to send a request or we're going to send some data, and we might get data back. We may not get data back, but that's the extent of it. With TCP, there's actually a lot of handshaking back and forth, because not only do you send the data, you acknowledge, the other person acknowledges back to you to say, hey, I got your data. I've got it in the right order. We're good. Go to the next one. And so if we look at the little handshaking we have, the UDP is very quick. It's I send data, the server sends data, very straightforward. Whereas on TCP, we're going to be doing a lot of handshaking, opening a connection, handshake. Oh, acknowledge that I opened the handshaking I was received. Now come back through and request data. So there's a lot more to happen when you're going back and forth with TCP.
All right, and something to remember with the top diagram on the UDP section is that even though there's lines back and forth, it's not a guarantee that if I send the request, I'm going to get a response. Sometimes we're just sending data to the server and not really expecting a response. And with UDP, it's like Steve said, it's fire and forget. You're just going to put the packet out there, you're going to send the data, and if it gets there, it gets there. If it doesn't, oh well. And you're not looking for a response from the server. Where with TCP, you set up that initial connection, you're guaranteed that you're going to get an acknowledgement back that all the data was sent and it was received in the right order.
Now, there is a protocol, though, that was used in gaming years ago that we typically aren't using today, and even a lot of our hardware, and that's called IPX. Now, IPX was something, it's a Novell networking standard. It worked really well for gamers and players on a small network, on your own private network. not so suited for large networking at all.
Yeah. I remember playing things like Doom or Quake on a local area network in college and flooding the network so that, it just took it right on down. Nobody else could do anything because we were playing a game that just didn't work well on the network.
Well, and some of the early game makers like StarCraft, originally on the CDs, it only had IPX protocol at all. It was a later patch to put in TCP access.
So TCP and UDP are common today, right? Game makers can use them today and use them. If you're going to get down into that low-level stuff where IPX is kind of outdated, do we have something that's more common today that we can use to develop games?
We have another one called WebSockets, and that one is starting to be used more and more people are playing games over a website. WebSockets themselves were something that's fairly new. They started in 2010, and it was supported by Chrome and Firefox or Safari. Now, today, all the major browsers will support it, but it allows you to do a two-way communication. So you're not only just sending data, but that's where you're getting your response back as well. And what's handy about it is that it's supporting and using port 80. So you don't have to set up a special firewall to go out. I know my younger son, when he set up a Minecraft server in the house on his machine, he had to open up ports for people to be able to play through and talk to.
Sure.
Well, with port 80, the communication is there anyways. It's built in because of everyone wanting to use their browser for everything.
Yeah, it also supports network address translation, which happens on a lot of routers where you're using private internal IP addresses on, in your house, et cetera, but you only have one public IP address. By using port 80 in WebSockets, we can send the data from the server, which is out on the live internet, across your router and be able to go into your private internet section and be able to establish communication back and forth so that we can have more and more clients and we don't run into this whole issue of not being able to get the packets through because it's not being delivered on port 80 and avoid a network address translation issue.
Well, and also WebSockets does support secure connections as well and sending binary data, not just text data that you would get in the browser. So for speed purposes, binary data might be a better option for testing and doing all the evaluation. And what we're going to be doing today for WebSockets, we're going to be using text versions, not binary, to make it a little bit more readable. Now, there's a lot of different implementations of WebSockets, and the APIs are done in JavaScript and C#, and there even is a C++ implementation in the Boost libraries.
Wow.
Now, I haven't used the Boost libraries much myself, and it was when I've had some students look at them and try and set them up, a lot of people have find it very hard. The documentation for how to set up WebSockets using the Boost libraries is not really straightforward. So if any of you out there want to improve some of those documentations for the Boost library, you might want to take a look at it, maybe go do some good samples using it. But most of the frameworks are going to have the same kinds of things. All the different frameworks are going to use and have things for callbacks on when the connection is open, when a connection is closed. They're going to have it to where when you get a message or data transferred to you, or when there's an error. So those are going to be callbacks that are automatically handled for you. Well, you get to set the callbacks for each of those. And so the library that you utilize, once it gets those kinds of information, it'll forward that over to your callbacks. Now, just a quick comparison. So we've talked about so far TCP, UDP, and WebSockets. And TCP, obviously, we're connecting to the server. We're passing data back and forth with handshaking, very reliable, little on the slower side, higher amounts of data being transferred. UDP being connectionless, it's lower overhead, faster connection back and forth. And WebSockets, using things in websites, connecting it like TCP, allowing you to stream data. That's kind of nice and important at times. Yep. But it's not something only for websites. You can use it in mobile apps. You can use it in iOS. You can use it in Windows Phone and Android. You can use it in any different kinds of platform.
So I want to touch on something that you said with the slower for TCP, in that we're not talking about it's slow. We're talking about that it's slower in comparison to UDP, right? Yes. So you're going to get fast speeds with TCP. It's being used across the internet today, so it's fast. But when compared to UDP, it's a little slower because of the handshake and reliability that you get.
But I mean, depending on the game, the reliability is very important, obviously.
Yeah.
So a lot of this is how you architect your game and what your game is really about. So you want to take a look at that. And a lot of people, they make a project, they make a sample, they don't look at the architecture, they don't look back if they're making a change. You may want to do those kinds of things because looking at how a change affects your overall architecture can really dramatically change your game later on. There were games to where they didn't even put multiplayer in until an afterthought at the very end. And of course, the multiplayer aspect really changes the game itself. So I do have a couple links for some samples for people, websocket.org and buildnewgames.com/websockets for some samples and lists of various servers that we have available. But I think right now, I wanted to give a nice quick overview of networking and some of the basics, because having even a small amount of knowledge in the basics when we're starting out can help us in the long run.
Yeah, and we're going to see a lot more on WebSockets as we go through the rest of the modules today. We got a lot of examples using that, plus a couple with, just some basic TCP stuff.
So we're going to take a 10-minute break, and when we come back, we'll start talking about the various Azure resources that we can use in our game making.
See you soon. And we're back. Did you miss us? I know I did. I missed you guys so much. How about you, Steve?
Well, I definitely missed everyone out there.
Yeah.
Because that's the thing, is that we're out here to share all this stuff with them because we have done all this stuff in the gaming realm. And we've done a lot of these things in Azure too. And that's what the next topic we're going to be talking about is some of the resources in Azure that we can utilize for our game making and being able to have everything as part of it. Now, Michael, have you done very much in Azure at all yet?
I've been using Azure for a while, so I've done quite a bit in Azure.
Yeah, I've done some of my own personal projects for the last 5 years using back data in Azure and SQL servers and databases up in Azure. So it's something that is very handy to use, and I believe Microsoft actually gives a benefit in the MSDN subscription to utilize Azure as a test system.
Yeah. You get, I think, $150 a month of Azure credit to spend as part of your MSDN subscription.
Well, and we just also announced something for students, to where students do get a added benefit in their DreamSpark now as well, too. So if you hadn't heard that, check out the DreamSpark website as well to get some of your benefits for doing Azure yourself. So what we're going to talk about this time is more of the resources themselves. Why using the cloud? And talking about the virtual machines, cloud services, and web apps, talking about things we can store, and then other additional resources that we have available to us. Now, the big reason is why use the cloud? Now, the cloud allows you to rapidly set up and drive things from a business priority, but allows you to scale and to meet demands. Now, Michael, you and I, we both worked for other places before joining Microsoft.
Sure.
And whenever I needed to request a new server for a project, it always was, I request it, and they're like, yeah, you might get it in a month or two.
A month? There's places I worked at that took 6 months to get a server up and running.
Yeah, and the thing is that being able to request something and being able to have it up and running and test it is a difficult thing at times, and Azure is something that helps with that. But one of the other huge benefits is being able to scale. Now, if anyone's ever done a website to where they need to have a load balance website and have it scale because they're handling thousands of users an hour or even a minute, then you can understand that you need to be able to scale well. And Azure is a great example of being able to do that and has some great services for that, both on the website side, but also from scaling virtual machines to even load balancing internal things.
Yeah, so in my previous life, I used to do SharePoint installations. And we did some installations for some pretty big customers, and we would have upwards of 22,000 users, within a company, and we're putting SharePoint in as the intranet. And, having to, scale that manually was always a chore, and being able to go through and figure out, well, how many servers do I need? Being able to request that up front, because you've always got that lead time of getting the servers back. Then you've got to configure them and set them up and do all the stuff that you have to do with SharePoint, it's always a pain just to have to know up front all of that detail so that you have enough for, what you need right now, plus growth from 6 months to a year down the line, because, making those requests later on is always painful.
Well, and if you're doing an e-commerce website, then what's going to happen is on Cyber Monday, or maybe even Black Friday, that you might get tons, millions of users hitting. And you need to be able to support that. Now, unfortunately, if you're going to try and scale and choose when you're choosing your server, how big do you really need? How much space do you need? You have to keep that one in mind. Now, the rest of the year, you might not need that kind of storage at all or that much power. But on Cyber Monday, you really will need that kind of bandwidth and power. So you really need to, Azure and using the cloud is something that allows you to scale up or down very nicely based on your demand. And if you need to be able to do that, that's great. Now, how does this apply to gaming, Michael?
You know what? That's an excellent question, considering we're in a back-end for gaming session.
Yeah, we're not in an e-commerce making website session. So we're in a back-end gaming one. Now, do you know of any game recently in recent memory that kind of their back end failed? It couldn't support the number of users that were there.
I remember you telling me something about this, but it's fading from my memory. What game was that? It was a Civilization?
SimCity.
SimCity, right? I knew I was close.
You were very close. But SimCity, actually, they launched their game servers, and what ended up happening is they were too popular. So I could log on and get into my city. But the beauty of that new SimCity game was actually that you could play with your friends. So my cities could actually tie into your cities. And this way we could all have it where I could set up something where my cities were mainly academic and had people living there, and your cities could be maybe industrial, and then they could have the flow of people back and forth between them. Well, when I can log in, but you can't because you can't get into the server, that doesn't help at all for being able to have the multiplayer. And I think that if the traditional scenario of, hey, we need to have some new servers up and running, we need it now because we need to do it, they have to purchase servers, put them up, distribute around the world, or put things in different co-location places. It makes it very difficult to be able to have a easily scaled system when you're doing it all yourself.
So we've already talked about using Azure for games with a game like Ascent, right? Age of Ascent. So we have some other examples too of Azure being used as a backend for games, other than as a failure, right? So, when we had the Xbox One launch, we also launched with Titanfall, and if I remember correctly, that used Azure as the back end for a lot of its, multiplayer gameplay. So we've got some good examples too of, this is how we can do backends for games correctly, even.
Well, and what's really a nice thing about Titanfall story is they did a private beta, and I don't know if you got into the private beta. I didn't.
Yeah, me either. I wasn't important enough.
Neither was I, but the nice thing is that after 2 days of a private beta, only 2 days, they said it was going so well, they opened it up to the general public. Now, I've never heard that from another game company at all. And by doing that, after that beta test ran, the Azure team was actually called by quite a few game companies to say, hey, can you do that same thing for us? Because we want to be able to scale and do everything as easy as what you did there for Titanfall. And Titanfall, they launched with over 100,000 servers in Azure. And when they need more servers, they spin up more servers. And if they have less people doing it and playing it at the time, they spin them down and save on cost. So it's actually an economical savings as well, too.
That's cool.
So the nice thing is with that is that if your game does get very popular, you can scale up. But obviously, a lot of people, when we're first starting out, your game is only a few players. And you don't want to be able to spend a lot of money on it. And you don't want to spend and buy a huge server that you're going to be running inside your house. and have that. So utilizing the cloud for doing these kinds of things is actually a very economical play as well.
So what types of things in the cloud are going to help us do that?
Well, there's a lot of things in the cloud that's going to help us, and what we're going to start off talking about is virtual machines, cloud services, and web apps. Most games are actually going to want these kinds of things in there, and we're going to start off with the virtual machines and start talking about those. Now, virtual machines, we have the ability to access them through scripting engines, RESTful APIs, or even from our management portal. Now, even though Azure is based in, it's a Microsoft product, you notice that the types of virtual machines you can put up, Linux is a very key player there as well. Mm-hmm. Because Linux is something that a lot of people end up utilizing. For instance, Minecraft, which is a great game for Microsoft, right now, Mojang did a great job of the game, and it's now part of the Microsoft family. And you can actually run the Minecraft server on Linux. So I know my son actually runs a Minecraft server on an Azure account, on a Windows server though. I asked him which he wanted, Linux or Windows, and he goes, he doesn't know how to use Linux, so he wants Windows. I'm like, okay, that's fine. But you can utilize Linux or Windows, any size VM, but we also have it set up to where it can optimize for computing, it can optimize for network traffic. We even have a version of servers that has a 40 gigabit network connect card in there.
Yeah, and the thing to remember about using a virtual machine, though, is that you're in complete control. You're just going to get the bare OS and some management tools so that you can manage it from your console. But in the end, it's much like the OSI stack. It's bare bones. You've got everything, and you're in complete control over what goes onto that server and how it's going to be used and how it's going to operate. So you create your virtual machine, and it's just big ball clay, and you get to mold it any way that you want, as opposed to some of the other services that build on top of virtual machines, and we provide some functionality there.
Right, and well, the other thing, the next topic is, and that builds on virtual machines, is actually cloud services. And cloud services actually run your own code. You don't have to worry about doing patches either once a week or once a month on the operating system. You write your code and you run that inside of that virtual machine, and you can scale that. Now, you can even separate the logic out to run smaller things, and those are things called like microservices. And I know there's an upcoming MVA on microservices that our old boss, Bob Familiar, is actually doing in the next few weeks.
Yep.
And what that is allowing you to be able to separate out your logic and your services using other things like queues and other kind of things to allow you to separate out the concerns. And any computer science person, the separation of concerns is something that you're very familiar with, being able to say that, okay, the reading input or doing network traffic or doing the display and the GUI, those are all separating out the concerns. You wouldn't want to be sitting there and waiting in your game for traffic from the internet to come, and then it slows down your display.
So cloud services are similar to, in Linux terms, it would be a daemon or a Windows service in Windows, but specialized so that we can deploy it and make it redundant and fault tolerant, all that other kind of good stuff. And you don't have to worry about all the other fluff around managing a virtual machine. We do all that for you in the Azure side, and you just worry about the application, that service, providing the functionality. And you can just isolate it, get it ready, and just deploy it into a cloud service, and it's running.
So that means that I don't have to actually upgrade and patch my operating systems for security holes anymore?
No, not like you did with like a virtual machine, right? If you install it, it's your OS. You're in charge of it. It's not like when Microsoft releases a patch for something, even high security ones, that it's going to apply that to your VM, right? You've got control over it, and you're going to have to apply and update all those patches. When it's a cloud service, there's no VM for you to manage. That's all done behind the scenes. It's running in essentially a small box, that application isolated box that you get, and you have to make sure that you just update your code. You don't need to worry about all of the other types of patches and things like that. It's hands off.
Well, I mean, I became a developer, and partly is because I don't like doing all that IT management. So having it to where the operating system is handled for me and all the patches and setting up of things like IAS and controlling all that for me is something I kind of like. Now,
Because I'm a developer, not an IT pro.
And we do have a lot of IT pros that we work with, and some people they love doing that, and that's their job. And unfortunately, some people thought that with the cloud, that meant they didn't have to do any of their IT pro type of jobs and work. And it's like, no, you have just as much, that's for sure.
Yeah, but Azure makes it easier for you to do that, So,
absolutely.
A couple of points and clicks, you just use a web app and you're all set.
Now, speaking of web apps, most games are actually going to need to have, or should actually have, a website. And we went to this app services model, and so they're now called web apps. Now, you should have a website for your game or your application that you're making. And especially in Age of Ascent, I mean, their game itself is a website. Now, the nice thing is that with the websites in Azure, you can utilize any language, open source, .NET, anything, even connecting to databases, any kind of framework, and using any tool. You can even use your Mac for doing things.
That's really cool. Can you show us?
Well, then let's switch over, and I'm going to go to the Azure portal. I've logged in, and we're going to do a couple things with this. Now, Michael, if we're going to be making a game, and we're going to be doing things, as I said, I want to be able to make a website. So I'm going to come to the lower left-hand side here and say New.
So what is this that you've got up right now?
This right now is actually the portal itself. This is the new Azure portal.
Ah, it looks spiffy.
It's really nice because it shows you the health of all the systems, shows you how much credit you have left, and how many days you have left. I've not used this account very much in the last month.
And that's if you're running a subscription that's based on a credit.
Correct.
So if you're running with a credit card subscription or pay-as-you-go, that would show you how much you've used.
It would show you your bill and how much resources you've utilized.
That's handy.
Very handy, because in the older portal, it didn't have a really good way of showing and displaying that. So the new Azure portal is a really nice usage. So I'm going to come down here to say New, and that's a place to be able to create anything. You come down through the list, and I'm going to go down through here and say Make a New Web, and I can choose, all these are our new app service models. I'm going to say Make a New Web App. And from here, I can even choose it from a gallery. I can choose from a shared plan, shared resources, where I want to host it from. Now, if I want to, one of the great things about doing the Azure portal, I'm going to stop that. I'm going to go to the actual marketplace, because if I come to here, there's a lot of pre-made web apps already set up for me. So I have the ability of doing a WordPress site. Now, WordPress is actually a PHP-based system. So it supports that quite nicely, all the way to a .NET Nuke, which is .NET-based.
Yeah.
Joomla, or, I mean, lots of different ones. Node.js.
Drupal in there.
Yes, even Drupal.
Yeah.
Jenga. I mean, every time I come into this, there are totally different things in here. The Azure team works so hard, they keep adding new features. I think I heard it's like making changes at the rate of like every 36 hours.
Wow,
which is,
that's fast.
It's an unbelievable rate. And so I'm going to just make a really simple website using WordPress for our little game and sample that we're going to be making. And so I'm going to say, it's going to make a small group here, a WordPress group, a resource group for us. And it's going to allow me to say, make our URL. So I'm going to call this one the Azure Gaming MVA website. And that little checkbox will tell me that it has not been taken. I hope it's not taken yet, so that's a good thing. We will utilize and create a brand new service plan. So we'll just call it our MVA plan. And we'll do a standard website. North Central US, well, we're not in the North Central US, so I think I'm going to choose where I want to be able to have my application, my website.
Okay.
And since right now we're in the West US, I think I'll choose West US. I could choose Japan, but it might slow it down a little bit for some of our things here locally. Configure our database. And of course, that uses MySQL. And what it's going to be doing is setting all this stuff up for me. It's putting it and defaulted here to Brazil. I don't think I need Brazil if we're going to be.
That's a little far for a database connection.
Just a little bit. So definitely when you're going through all the settings in this and for setting all this up, make sure you check where your locations are. The defaults might be somewhere that you're not anticipating. And then I set up a storage account. As I said, I've got, I'll just create a new storage account for this real quick.
So you're just following all the little red marks on the side there to know which settings you need to fix up in order for the create button to light up, right?
Absolutely. Going step by step through, and then on the main page here, it's going to allow me to notify when that website actually gets created.
So put a tile on your page already for you.
Yes. Now, earlier I actually made one for a virtual machine, and we're going to be running some samples on that later in the next section. Now, virtual machines, as we said before, you can come here and you have some default ones from Ubuntu, a SharePoint server farm. So, like you said in your previous life to where you were doing SharePoint installs.
Yeah. I'd love to have this. I mean, like 7 clicks and you can get a full-blown isolated SharePoint farm, and you don't have to worry about setting up 7 different servers and different configurations and Kerberos and all of that other stuff that you've got to do in order to set up SharePoint. It's like point and click. We need that for like a Minecraft server, right? We just need point and click and have it set it up so that you don't have to go through the whole setup process of setting up, Minecraft on your own VM. That'd be awesome.
Well, we do have, and I believe it's probably not listed here in this one, in the gallery. It actually is.
Oh,
so we do have.
My wish is granted.
Your wish is granted, and we do have one made by Bitnami, but also one made by Microsoft. So we could sit here and just click on the create button from the gallery, set up all of the different things for the host name, passwords, usernames, and that will automatically start up again. It started up as South Central US for me. So be careful. You want to have your game server close to you. You don't want it to be somewhere that's
close to you or close to your players.
Close to the players, yes. And you don't want to be able to have that to where it's going to be causing a great delay in the game, especially if it's Minecraft.
Right. So you're going to go ahead and build one of these?
We can build one Minecraft server if you'd like.
Yeah, let's set that up.
Now, the nice thing is with this, it is available. MVA Minecraft is available.
Nice.
So we'll just use that as the username as well. Now, they do actually, when you're creating this, have to do a very strict password. So things like password 123 that I just typed in does not work. You do have to have a little bit more security. So I added a 4 to the end.
Okay.
So, and I'll make that in the West US as well here. And we'll sit there and make it. So we're going to have a fully functioning Minecraft server shortly.
Nice.
And that'll be sitting there. We'll be able to even remote desktop over to it, be able to control it. And this way, it's the simplest way for, let's say, kids or schools or anyone else to be able to have one central server that they can utilize and be able to do it. Now, I don't have Minecraft installed here right now. I personally only have the Xbox and Xbox One copies. I don't have the PC version myself.
Well, maybe during one of the breaks we'll get that installed.
That's good. We might be able to get that installed there for it. And now the thing is that when you do have a server that's set up, you do get the ability to do, if it's Linux, SSH connection over to it. If it's Windows, you are able to do a remote desktop over to it. On the top, they have a little connect button, and that'll open up a file for the remote connection. So at that point in time, I can remote over to it, and I do need to log into my machine using the name of the server. So that was...
So you're connecting into a VM that you created earlier today, right?
Yes, I created this one earlier today because a lot of times it does take a few minutes, up to 10 minutes. I created one time that had 32 cores, and that took over 10 minutes to create. But it was 32 cores, so and 448 gig of RAM.
You're saying 32 cores, and I'm like 10 minutes? That's all?
Yeah.
It just took 10 minutes to pull up a 32 core machine? That's awesome.
Yeah, and it had 448 gig of RAM as well, too. So it was a pretty hefty server overall. So I could understand why 10 minutes, that it wasn't that horrible. So we can remote desktop onto this and continue to be able to log in. And we're going to be using the server actually in the next section. But let's talk about some of the other services that we have in Azure as well. So start going back to storage.
Ooh, we're going to be able to store stuff?
All right.
We need to, right? So there's a lot of things in websites, and not websites, but games that, we need to store data, and they have different life cycles. So you might have some data that you need to keep essentially forever. It's game state, right? And other types of data might not be so long-lived, that it really just needs to stay around for a little bit of time and then kind of goes away, a lot more transient. For instance, if you're doing like an MMO, a massively multiplayer online game, which everybody wants to build, right? So in those types of games, you have some data that just does not live very long. When I was working on the plane shift stuff, we had a system called Dead Reckoning, which was really just a system to be able to track all the players and where they were and be able to send that information down to the other players that were playing so that we could update, very reliably, I'm here in the world, and Joe's over here and Steve's over here, and be able to get that data to the clients in really fast periods of time. In fact, we were sending packets from the client to the server every 500 milliseconds. That data was essentially stale within 3 seconds. If we had no packets within 3 seconds, we were like, well, you're now disconnected. And if it was received a packet that was 3 seconds old, well, we had to drop it because, well, it's 3 seconds old. 3 seconds is too long. So we need some storage options to be able to hold data that doesn't take a long time, it doesn't stay around a long time, as well as game state data like, where are the plants and vegetation in the world, or where do we have houses, and possibly even what damage has been done. So, we've got lots of different types of data that we need to store. So what are our options for storing data in Azure, Steve?
Well, from the standpoint of the databases that we have available, we have both relational and NoSQL databases. A lot of companies, a lot of games are going to NoSQL. Now, we have a fairly new NoSQL database system called DocumentDB, and I know that there was just an MVA recorded on that. So if you want to have a huge amount of information on DocumentDB, it's a JSON document system, but take a look at that MVA. That'll give you some great information on that. Overall, it's a JSON document, so every row is just a JSON document that can be read and written to. So you can store any kind of data there. Now, Michael, the idea of a normal SQL server versus a NoSQL.
Yeah, what is NoSQL? I mean, it sounds like you just don't have a SQL database.
No, it's NoSQL stands for not only SQL. So it's that you're not going to be only using SQL Server, or you're not going to only use SQL commands, but you'll be able to do other things. In the DocumentDB realm, they actually have JavaScript as its scripting engine, and where you can do queries and link queries and those kinds of things. So there's a lot of things that you can do with it, but a lot of the NoSQL systems are meant for extremely large amounts of data.
So we're talking big data.
Very big data. And what it's going to be doing is that you're going to be able to store tons of data. The basic system with DocumentDB, it starts at 10 gig for that. And starting out, 10 gig is not a bad size. So you want to be able to have as much as you want, but you have to also think from the standpoint of if you're doing a relational database, you think in the terms of classes and tables and how everything's related. In a NoSQL type of frame, what you end up doing is you think about what is my document? What is my one level that I can read at one time? So I read one thing, and that's all my data. I don't do cross-reference. I don't do joining. And so a lot of times that can be actually a lot faster for things.
So how does that differ from something like blob storage where, you've got just a chunk that you want to store? I mean, why wouldn't we just use blob storage over going to something like a NoSQL database?
Well, blob storage could actually be utilized for doing it. Now, your typical file I/O commands can't be used on blob storage. You have to use blob storage commands, or you could do it over a website if you open it up and have it freely available. You can have your blobs as containers that are open to the world to read. Now, you can also set up privacy and security, which I know you're going to be talking about security and authentication a little bit later, Michael.
Sure.
And what it's going to be doing is you can set that container up to say that people with my application or my security keys have permissions. Now, you have to utilize the client libraries for that and to be able to pull it in. You can put things up there like videos and streaming systems or videos or files. You could pull down more resources. You can pull and lots of things to like put new levels, new skins, new images that are going to be used in the game. So you can use blob storage for a lot of various things, but there is no relationship between one thing to the other. If I want to have something to say, this is a piece of equipment that belongs to someone, belongs to this player, a relational database, or maybe even a NoSQL document that says, here is my character, and then here's all the things my character owns inside that one document. So you could do it with a NoSQL or with a relational database in that case. But just a plain blob storage really wouldn't get you the same type of information.
So far all these options sound like they're pretty permanent, right? So we're actually putting stuff on disk and storing it for a longer period of time. What do we have available in Azure for shorter time stuff, similar to something like the Dead Reckoning system I was talking about earlier?
Well, one of the things that we have with that is actually we're using Redis cache now. That's one of the options we have in Azure. And that's a fairly standard system that people are utilizing. It's clustered. It does have the ability to go from 250 meg up to 26 gig in size. So this way you could set it up. I've seen demos. If you around the US, I know we've been doing some Azure dev camps and web camps, and we've been doing demos of the Redis caching to do things like a chat server. So instead of doing any logic with a chat server and having a server do something, the Redis cache can actually be set up as a publish subscribe method. So a pub sub model. So this way I can say, if there's any chat messages that come up, I automatically get them pushed to me.
Yeah, and chat's something where you don't necessarily want to keep it around for a long time. So it's a great thing just to put into an in-memory store like a cache server and then just pump it right back out to all of your clients.
Absolutely. And the nice thing is by doing that in memory, and especially if you have a large number of players, having that in memory and being able to send that out is very handy. And the other thing is that you don't have to have the logic, which we're going to have in the next section. You don't have to add that logic to your backend code for doing the chat or handling it. You just have to handle the subscription to the Redis cache for new things.
So can we flip over and see how we can create databases or Redis cache or blob storage in Azure?
Absolutely. So I'm going to come down to the new, like I did on the other one before.
So this isn't going to be any harder than it was the last time, right?
There's going to be maybe some slightly different button clicks, but there's only still a few button clicks for doing
it. All right, that's good, because I like few button clicks.
Absolutely, and the new system here for the new portal actually does a lot of these things they've set it up to be a lot easier for finding things.
I like the fact that we've got a recently used list there.
Yes.
So if I want to create multiple Minecraft servers, it's only a click away.
Absolutely. Or if you make a server and then you forget the password or the username.
Yeah, that's never good.
No, I had one student that actually every class he had to remake his virtual machine because he forgot the password every time. And that just, it doesn't help, and you want to be able to remember what they are, especially when you're doing something quick. So if I come down to the list here, and I'm going to you have various services. We're going to talk about the media services and everything in a second.
Yeah, so
you have data and storage.
Right? There we go.
I can make my SQL database. That's a fully managed SQL database. document DB, a storage account, a Redis cache. I'll start off just making a quick storage account, which I did make one earlier for the Minecraft server. So we'll set up this one up as Azure Gaming. And we get to say where the location is. It's defaulting here for East US. I guess that's good enough for this demo here.
So is this table storage or blob storage, or are they the same thing?
Well, what this one is going to do for the storage account is going to set up table storage, blob storage, queue storage, all of that inside of the one. And I don't know why the virtual machine popped up, but we'll go back to the store. It's still making the storage account. So it does take a minute or two for the storage account to come up.
I think it popped up because it finished running.
Yeah,
finished installing it, gave you a nice neat tile there.
It did install. It did make a nice one for that server that got created. Now, the nice thing is that all of these accounts for doing the blob storage and everything else are under the one storage account. So from there, I can have blob storage. I can have table storage, which is another NoSQL database system, and you also have queues. Now, a queue is like it is on anything inside of Windows. It's like the queue of getting into a line. I put data onto the queue, I can pop things off.
So in terms of gaming, right, because we're here about doing gaming, what types of services would use each of these different storage accounts, right? So we've got 3 different storage accounts, but we need to have, how do we relate that to our game, is essentially?
Well, the way, Michael, I would do that is if, let's say that you had limited number of resources or limited number of players, like you were doing a beta test, and you wanted to only limit 5 people or maybe 10 people at a time, you might actually queue up all those people for logging in utilizing a queue. And that way you can say, okay, well, these first X number of people get in, and then and do that. Now, the other thing is that you could utilize a queue to do communication between the different parts of your game. And that is one thing that a lot of services end up doing. So what they'll do is, I got a message coming in from a game player, I might queue that up and put that into a queue, and from there, let a back-end server actually do all the work on it. So go ahead.
So I was thinking here, you gave me an idea with that. So if I had, a game that needed to have some type of long-running process in the background, I could send something and put it into the queue and have my process pick that up, work on it, and then drop something into blob storage where the application can pick it back up again. And so we can have some asynchronicity there without having the application sitting there waiting for this process to run and the user sitting there with a nice little, some type of wait icon, right? So you just kind of fire it off, put it into the queue, let the process work on it. And, once you put it into the queue, the result is, hey, I'm going to put the result at this location. And then the app can sit there, your game can sit there and just pull to see, hey, is that done yet? Is that done yet? Is that done yet? Kind of like, are we there yet? Right? So, that type of a process where you turn it into a polling instead of a waiting type of a game. Not game, but it's that game, not your game.
All right. So back in Azure, the account did come up and it'll list out the different blob containers that you have on the left-hand side, the queues that you have created, the tables that you have made. And one of the things that's really interesting about table storage or NoSQL storage is the fact that every single, unfortunately, the new portal does have an issue that you can't really zoom in on it well. So I'm gonna launch Zoom It because you want to be able to see that a little bit clearer here. We need to be able to zoom in on this. And one of the things that I found with the new portal, it does not, I love my touch screens, but it does not zoom in really well with this one at all, these portal. All right. So okay, I'm not sure where it all went off to. Okay, but the nice thing is that what I was getting to with table storage and NoSQL is that every row actually can be a different schema, a data schema. And so for traditional database people, that it can be kind of a little disconcerting because people spend days and weeks and months on a schema for a database. And the nice thing is, the thing I like is that all of a sudden you need to add a new field. Let's say that you needed to add a field to say, is the player left-handed or right-handed? Well, that might not be something that you added to the original database, but that's something that you could add to a NoSQL for, all future users have that defined. Now, there's one other storage system that we didn't talk about yet, and that is the file storage system. That is a system that's in Azure that allows you to do standard file I/O. And that allows you to be able to have your file I/O commands that you would run locally to be where you could have them and run them up in Azure. Now, Michael, from the standpoint of if we're making a game, if we would want to have, what would we want to have a standard file system like that could be shared? What do you think we could use that for?
Oh, there's lots of different things I think you could use just standard file I/O for. Simple configuration data, for example, is one thing that you might want to just put out to a file and store it and be able to read that back. Let's see, what else? Do you have another idea? I mean, I came up with one. What about you?
Well, the other things, like you could do your logging or any kind of tracking of data on those
Logging,
as well.
that's a good one.
You can store a lot of those things off to a central location. And the nice thing is about the file system, you can, on a virtual machine, create a virtual hard drive in blob storage, but that can only be logged onto one virtual machine. You can't have that tied into multiple. But the file system can be tied into multiple.
I got another one. Similar to the Xbox service right now where you can do the in-game videos, you could do that in file storage because that's going to be fast enough to actually record all of the frames that are going on, store that out to an image, even if you want to do a single screenshot or multiple images in order to be able to create an entire video, let's say, a little 6-second Vine video of what your game is doing at that point in time and be able to dump that into file storage and then later on move that into blob storage where you can, get access to it from many different clients.
Well, and I think actually that's a good point is you mentioned Vine, but then there's other social media systems, whether it's Facebook, Twitter, any of the other social media systems. You want to be able to utilize those in your game and share them because people love sharing their progress, something funny that happened. All of a sudden you see something that you might see the guy's head coming through the middle of a wall or something. People love taking snapshots and videos of those and sharing them with other people. But as a developer, being able to utilize those and share it actually gets people to understand your game and see how it's going and how it's being built. And when you're trying to do things like various contests, like the Imagine Cup, Microsoft runs that as it, and there is a game category in that. So utilizing something like that to be able to get people to look at it for larger contests like that is kind of a nice thing.
Yeah. So we've done VMs, we've done some storage option and websites. What are some of the other services that we have in Azure that our users can use?
Well, there's a lot of other services. Now, the other ones that we have listed, and we'll just list a few of these as we're going through here, is mobile applications. It used to be called mobile services, and now it's called mobile apps because it's under the app service system. But it's a way of actually being a data proxy between your game and maybe a database or even something where it can keep offline data.
Yeah, so these I see a lot of ways that we can use games to leverage some of these services that we have here. Mobile apps being able, like you say, using it as a proxy between the client and your game service in the back end. So that's your front end point that you start everything from.
Well, and the other thing that's important is mobile gaming right now is huge. People are playing games on their phones all the time. Now they shouldn't be at a traffic light, but whether they're doing it while they're waiting for a doctor's appointment or between meetings, people are sitting there playing games on their devices. And a lot of times they may not have an internet connection. They're on a tablet, they don't have Wi-Fi connection. And so keeping it where you have offline data as well can be very handy.
Sure.
Now, other things like the notification hubs or allow you to be able to do things like pushing data and pushing data up to the cloud in large quantities. And what's one of the other services that we have listed out?
Well, actually, I was thinking about the event notification services and how we can leverage that to create, some turn-based games, right? So that would be really awesome. I'm not actually on my phone because, I'm off doing something else, but I can get a notification that, hey, Steve just played, made his move, and now it's my turn. So I can get a notification that says, hey, it's your turn. I can open up my notification area on my mobile device and be able to see that, hey, it's my turn. Let me open that up. Let me make my turn. And, now Steve is going to get notified that it's his turn to play. So, lots of cool things with event and notification hubs that you can use to really enhance and draw your player back to your game once they've actually moved on to something else.
And I like that because knowing that you played your turn and it's waiting for me, if I had to go back into the game to figure out if I had a turn waiting, like there was one game, Michael, you and I were playing that we had to do that. Yep. And that was, I think it's still my turn in that game because I never went back into it.
Yeah, I think so too.
So
I've been waiting, I think 6 months.
I think
just a short time.
I think you have. So having that push notification is very important for this and to keep the game rolling. Now, the other thing that we do have is the ability to do media services in Azure. And that's things like streaming video and having live video to be able streamed as well. So you could do things like a cutscene or demos of your video or your game right inside of Azure.
Absolutely. It just makes it so easy for you to, take a piece of video in whatever format that you have it in right now. So, if you develop your cutscene and you produce it and you've got it and it's, let's say it's just in, WMA format, right? But your game is being pushed out to Android, it's being pushed out to Windows Phone, Windows desktops, and iOS. In order to actually leverage that on multiple devices, you'd actually have to translate that from, or transcode actually in video terms, from WMA to, the iOS format, H.264, whatever the devices are going to support. Media services can do that for you. And so now you're not relying on a whole production and group. You could actually do a lot of this yourself. Just produce the one video, put it up in Azure Media Services, and allow that to do the transcoding for you, even on the fly. It doesn't even have to be done up front. Probably for cutscenes, I'd want to do it up front, just because it's going to make the cutscene a lot faster. May even download that to the device from my blob storage or wherever, just to make it easier. But streaming is really cool too.
Well, and the thing is that sometimes phone manufacturers, I know on Android, when it came to version 4, they actually changed streaming video versions that they support. So they went from a version 3 to a version 4 of a certain library for streaming. So if you encoded it one way, now on the new version of phone operating system, they can't actually work. So you have to have the new one. So that is something that is a little tricky to be able to support. And it's nice that Azure has that kind of support built in to do those things. Now, the last one that we have listed on our slide deck is machine learning.
Ooh, are we talking Skynet here?
Yes, we are building Skynet into our system, and we are building it in Azure. So it allows you to take massive amounts of data and look for and analyze things, could be hidden patterns, or to do predictive outcomes. Now, Michael and I were at a Tech Ready conference last year when we were actually introduced to the machine learning originally. And they did an evaluation on the keynote address and said, we put in all the history of all the machine learning, of all the keynote addresses, and we predict that it should be a 4.72 for the ranking for the keynote. And it actually ended up being 4.74. So the more data they have to do the analysis, the accurate it is. Some historical things that they've done with it recently, they predicted 15 out of the 16 World Cup games, 22 out of 24 of the Oscar winners. So they've been using it, Microsoft's been using it for demoing and putting in lots of different things, not just very statistical. But how could we use that in our game, Michael?
There's, I think, some really cool ways that we could use this in our game. For instance, you can grab all of your data that you are typically, for example, in games where you wander around, right? And one of the things that I see a lot of game studios doing today is they're taking that data and they're creating heat maps out of that data to find out, like, where is it that people are going. And you can start using that data to make your levels better, but you could also start using that data in the back end for your mobs, right? Your monsters or beasts, and being able to make them a little bit smarter as to, 50% of the time, the first time a player comes through this map, he's going to go left instead of right. Right? So now your monster can have that type of knowledge ahead of time so that, he can adapt to what most of the time the player is going to do, increasing the level of difficulty in your games over, some other games that might not have that type of information ahead of time.
Well, but how about even doing something like, you're mentioning kind of MMO type games, and Azure can support lots of different ones, from MMO and online servers to even the turn-based. But what about something like economics? A lot of the systems will actually try and make it to where they have a better economic system than other games.
Sure, you can use that data to, gather the economy of certain games. For example, like you're talking about SimCity or something like that, where your game is actually using currency to enhance the gameplay. You're responsible for building this and selling it over here, using that information to adjust how much a non-player character is going to buy your goods at, based on how is that trading in other places. You can definitely leverage that data to make your gameplay more realistic and model real-world economies.
So there's a lot of usage that we can have with these things, and there more and more features are added to Azure. Every quarter, every month, we seem to have more additions that are getting added to it, from machine learning to the video streaming, and all of these types of things can be utilized in the gaming industry. Well, I think right now it's about all the topics we had for going over the Azure resources that we have.
Yeah, I think that's it.
So we'll come back in about 10 minutes and start talking about actually setting up our game and being able to start doing some coding.
Yeah, so don't go too far, but we'll be right back.
All right, welcome back. And now we're going to actually get into some coding. I know we've been going through a lot of slides and a lot of things, kind of like background information so far. But now this one's going to get in a lot more on the coding side. And as developers, I think we enjoy coding a little bit more anyways.
I'm getting the jitters being out of Visual Studio for so long.
Yeah, and I'm glad I have it running right now in the background here.
Yeah, it makes you feel a little bit more at ease.
Absolutely. And so we're going to start off. This session is going to be talking about client server and a little bit of peer-to-peer architecture. And we're going to also then get into some actual code and some samples that we developed. We're going to look at some network topologies, just a quick overview, some peer-to-peer and client server, and looking at some information on data packets. So starting with network topologies and looking at how some of these things are made in games, and especially when we're looking at multiplayer games. Now, Michael, the one on the left here, peer-to-peer, that is a very common one if we were just making a game that does talk to each other and we weren't doing anything with a centralized server.
Sounds a lot like Doom and Quake models for peer-to-peer.
Absolutely. Now, if you notice, though, that they don't actually have every PC is not connected. The one in the lower left-hand corner, it looks like that's the host because everyone's connected to that one, but not everything is connected to each other. And you don't have to have it where everyone is connecting to each other like a full connected network graph. Mm-hmm. But you want to be able to make sure you at least have certain rules around how far people are away. The second one being a standard client server. Everyone talks to the server. No one's connecting or talking to each other. All the data communication is going directly through the centralized server. Now, your online games are going to be like that. All of the things like Minecraft, those are going to be running like that. Even though you can run your local server on your machine and run the client game on your machine too, you want to be able. That's still going to be a full client server type of architecture. Now, we'll talk a little bit more about the peer-to-peer, though, to start with, because peer-to-peer is a very classic way of doing it and can actually start and make our game simpler. A lot of the games that we grew up with, whether it was StarCraft, Diablo, Doom, Quake, they were all peer-to-peer. And, of course, we were doing it on dial-up. So that made it for a little bit hefty things. You had what's called modems, not cable modems that ran at 56K at the fastest. So for us to have a limited number, you had a lot of data that had to go through if you were the host of the server. And a lot of those original games even did some interesting things to where what they would do is, with peer-to-peer, you typically, a lot of times they would have the hosting software inside the client software.
Yep.
So one person would say, I'm going to be making the game. Here's my IP address, everyone, connect over to it. No standalone host software typically. And a lot of times you might have a lobby on a server, but you might still only have it where you're connecting and the lobby server is not actually doing anything in the game itself. It just got you connected together. And I remember that was in Battle.net, that was very much the way it was, especially with StarCraft.
Yeah, where the lobby really isn't responsible for communicating to every client. It's just responsible for, once a client connects as a central point to get into the game, it then hands off the communication to all the clients and says, okay, here are all the games that are going to be participating, here's their addresses and the ports that are in use for you to communicate to each other, and just then it's done and it's over. And it's sitting there ready, listening for other players to connect and form their own game.
So now, typically though, when we have a system and you're going to be hosting that game and you're setting it up, one person is the host. They set up the map, they set up all the rules, they set up everything, and they typically have like the power to do things like kicking people out of the game for being disruptive, or maybe their language or something else of that nature. And now the thing is that person always has to have a good internet connection, because their internet connection is what everyone is communicating in and out from in a peer-to-peer game. And now there are a lot of people that have some very bad connections. I was playing games to where they always pick my computer to be the host, but it was with people that were overseas, and my computer or my Xbox would be picked as the host, and it would be a very bad latency connection between everything, because the ping times between all the players were really bad for my machine, but they picked mine to be the one that was doing it.
So that's a really good example of where peer-to-peer is actually being used, or was being used at least, in even a modern game system. I mean, we've been talking about these historical games, but even as we get into the Xbox 360 days and Xbox Live and the multiplayer for games like Halo, it was similar to this lobby description that we had, where, as you went into the matchmaking process, that was the lobby. It was doing all the matchmaking. And then once the game actually started and it went through that countdown, 5, 4, 3, 2, 1, boom. At that point, the game became an entire hosted by one player in that peer-to-peer network, and everybody else was connecting and exchanging data. And typically what I saw was, the worst case scenario is the host didn't like whatever team was formed up for him to play with, and so he would turn off his Xbox, and there goes the entire game for everybody, and you're back in the lobby getting a new game set up. But this is something where, we're not even talking 10 years ago, that, we're still in games can use this type of a networking to be able to facilitate and have multiplayer games going on.
Now, the thing is, though, is that peer-to-peer, I'm directly communicating to you. I remember playing a game, it was a Jedi Knight game, and it was peer-to-peer. And the way I know it was peer-to-peer is the fact that they used a language called Lua for doing all of its scripting. And what I ended up doing is I changed, if it was a Star Wars-based game, and so I had a force power doing a force ball, and what I changed that power to, it actually did a force ball in 8 directions around me instantly at a super high powerful thing. And it evaluated on my machine, and then the network sent it out to all the players in the game. So at that point, I was able to kind of cheat at the game and make it so that, well, the whole idea of the damage and everything that went out, that was normal part of the communications. It's the whole effect that I cheated. And by a peer-to-peer, you actually had that ability to do
Wait,
those
are you
kinds of
actually
cheats.
on a webcast telling people you cheated at a game?
No, I actually modified that script in my game that I played against it. Now,
Okay, nice recovery there.
I
Nice
didn't
recovery.
use that. I used it with my online gaming friends for doing it. Now, of course, when we're also doing all of these kinds of things, we also need to know, though, when the host isn't there anymore. Like you said, someone just shut everything down because they didn't like the game. They were losing and they were being a poor sport or whatever.
Right.
Now, originally, a lot of those games, they would, if the connection was bad or something like that, they would actually shut it down and go to the lobby. But a lot of other times now, what they'll end up doing is rotating a host to a new one and finding a new host. But one of the things that they're going to end up doing for that kind of communication, though, is to know if your game or your player, your system is going, is they might use a heartbeat. And that heartbeat allows us to know that your game is still alive. You might not know that there's a player sitting at the keyboard, but you know that the game is still running and that they didn't have a power failure and now all of a sudden they don't have any connection at all. But also the idea of real-time thinking, to where knowing that, oh, I killed that monster that's standing next to you, you didn't kill it, so now you don't have to sit there and start attacking it and constantly doing it.
So let me ask you a question, Steve.
Yes.
Do you have a PSP?
Yes, I do have a PSP.
Does that use peer-to-peer networking?
Well, I mean, a lot of the games will end up utilizing a peer-to-peer type system.
Yeah, because I know people who have. I don't have one myself, but I've talked to people who have them, and they're talking about being able to just walk by other people with PSPs and have games being played.
My sons at PAX East, they were actually doing that all the time with their Game Boys, walking by and getting different badges and trophies and things of that nature from people all throughout the PAX East conference. So the whole idea of being able to have something that's quick, simple, and together is nice. But you do have to worry about cheating. You do have to worry about scaling, because peer-to-peer doesn't allow to do a lot of those kinds of things. You have to manage all that yourself.
So peer-to-peer sounds like something that's really good for a small number of clients or close networking, whereas our client server is going to be much more suited for large scale and being able to rapidly scale it up and down for things like massively multiplayer, even whether it's an RPG or if it's a first-person shooter, right?
So let's start talking about client server a little bit now.
Okay.
So similar to peer-to-peer, obviously examples, Minecraft, Age of Ascent, all the different online MMOs that are out there. So many MMOs out there nowadays, from Ultima Online to World of Warcraft, that it's hard to keep all of them straight. But the host is actually running separate code outside of the client game. And you could actually have a host, a Minecraft server running on Linux, but you're running on Windows. You can switch all of those up. And the server focuses just on the game logic itself. Now, the thing is that you also have things like Age of Ascent. They don't have the idea of one server app running. It is actually multiple parts to it. And when we get into later this afternoon after our breaks about the Age of Ascent, what you'll notice is that they actually are running 478 servers. And they split it up to doing a lot of very specific logic, like we talked about earlier, with the separation of concerns.
So with server-based and client server, you can do things, different ways of scaling, right? People talk about scaling up versus scaling out. And with their server, if you've architected it correctly and split things up right, you can do scaling out with multiple shards, multiple worlds for your larger games, with a lobby up front that does hey, choose your world, go into here. One of my favorite MMOs was from Turbine, Asheron's Call, and that's how we'd always start out. You do your login, pulls down a list of worlds from whatever master server or authentication server is out there, and then you choose your world, and that's where you go in, and most of your gameplay is sitting in those types of environments, and then you can back out and then go into a different world and play with other people. So the idea of a server in the big sense being just one app is really not the concept that we want to get across. It's that you're going to have different pieces, different functionality that's responsible, and you can pull them up and pull them down as needed. So you could have a character server that holds all of your character data, an authentication server to handle just authentication requests, as well as the game server for all of your game logic and handling millions of connections.
Well, and as you said, you can also scale each of them up. So if all of a sudden you had a trial or a test, then you could scale it to a larger server or a smaller server based on that. So instead of saying 1 core, you could go up to 4 cores or even all the way up to 32 cores for the server that you're running. Now that's if you're running a virtual machine. Now if you're doing it as cloud services, that's a different level of amount of processing power available to those.
Right, but the concept stays the same in being able to, add more hardware to the problem as opposed to creating more instances of your game server.
But sometimes more instances and smaller versions could actually work just as well.
Yes. Yep.
So it's really a balance, and you get to play with that balance to say, do I need more copies of the server, or do I want one copy that's bigger for it? Now, the next topic that I need to talk about before we actually get into the coding is data packets. Now, our data packets themselves are going to be the data that we're going to be sending out and sending across the wire. Now, one of the things that I did and I taught my class is the fact that for a lot of these, you might have, especially with TCP, you might be sending out raw data, and all this is just binary data sending across the wire. And by doing it, you may want a packet ID or a packet type format in there that says, oh, this is a logon packet, this is our data packet, this is a chat packet, this is an attack. I mean, all of the different types of communication that you might be doing. Now, you also have the ability of doing strings that might be fixed length or variable length. Fixed length obviously could be very wasteful at times, because if all of a sudden I say hi, but my minimum message length that I send is 256 characters of blank data every time, that would be very wasteful. And especially if you are paying for bandwidth in and out of your server, you don't want to be using all that if you don't need to. So having something that says, my string is hi, but it's 2 characters long, could be something that you would actually put into a binary string that you would do with like a TCP or UDP.
So some of the things that we want to keep in mind when we're talking about data packets is kind of like, why are we talking about this? And, when you're doing, large scale games, which, obviously we're talking about using cloud services as a back end, we want you to build games that are going to have millions of users, even if it's just, let's say, a couple thousand simultaneous, right? One thing that we've got to be concerned about is the size and the amount of data that we're sending back and forth between our client and our server, so that, as we're sending this data, we're going to keep it as small as possible and only send as much as we need to, so that we can make the game as responsive as possible, especially if it's real time. So if you're doing, even a small MMO or a chat server, you don't want to have it take several seconds for somebody to say hi and get to the server, and then the server send that back out to all the clients, and then they can see that information. But if you've done the right if you haven't done the right type of analysis of your data and your packets, etc., you can start sending very large packets, not knowing that you're just really sending 2 characters across that you want to send out, and you're going to increase the latency between each of the clients and the server itself. So this is why this becomes important, is because we want to make sure that we send only as much data as we need to and as often as we need to do it to improve responsiveness of our games.
And like I said, even in these online games, we're going to be doing things like heartbeats. Now, if we're sending a packet, do you think we could actually combine some of these data packets together, like a heartbeat and a chat message, or maybe an update for my position in the game?
You can, and that's possible, and some games actually do that. And one of the problems with that is that you don't want to have to wait too long. Usually what that involves is, as you're building out your networking stack, that if you want to bundle packets together, then as the first packet comes in, you delay it for a period of time to say, hey, are we going to have more packets that need to come through? And sometimes, the the longevity or the lifetime of the packet that you're holding on to expires by the time you actually send that data out. So you have to be careful of doing that. It's possible, games do it, and it can be really helpful because you're going to send multiple small packets off as one, and so it can get delivered faster. You just have to make sure that you're not holding up high priority packets, for some lower priority ones that are coming in after it.
Very good. Good thing on that. Now, the other thing is that we have between WebSockets and other things of that nature, they're using JSON, and JSON can be kind of wordy because it's text, and that's why you would have a binary format. Now, typically on WebSockets, you don't need to put lengths because it's very descriptive of saying this is this data packet, this is the data, this is the message, this is the position type of thing inside the JSON. So a sample chat packet could be something like an ID, as well as a player to say who said it, a message length, and then the message itself, all serialized in one binary packet going to TCP. Now, as we talked about optimizing a little bit a second ago, keeping the data to the correct sizes. If you only have 16 players maximum, an int or a long is overkill for this. And actually, this is one of the techniques that Age of Ascent used when they were developing the game, because they were trying to keep their amount of data minimal so they could have more players in the game. They originally were talking about 1 million players, and then figured out once they did the calculations for bandwidth and all the messaging, they couldn't support 1 million players. And so by optimizing their packets, their data packets, and minimizing all the things that they send out, that they really helped out doing a lot of having the support to do 100,000 simultaneous users. And now, obviously, a lot of your games might only be a few users, and optimizing might not be something you need to worry about when you're doing all that. And as developers, we always say we shouldn't prematurely optimize. But I know, Michael, both of us have seen that in a lot of cases where people are like, well, I'm going to optimize this real quick because, well, I have time to do that. And they don't really need to at the time.
Yeah, there's some cases where that is true, but when we're talking about, large scale games or even smaller scale games, you want to make sure that you're doing the optimization at the right time and data packets early as possible, because you want to make sure that you're going to be sending the right amount of data as fast as you can, because it's only going to improve performance. That's not a wrong place to do early optimization.
Absolutely. So what we're going to do now is switch over some code demos. So I've got Visual Studio up, and I made a small WebSocket server. And I made it.
The minute I saw that, my hand stopped shaking.
Okay.
That was good.
All right. So we're on Visual Studio. We're good. We're showing some really nice code, and we actually have a WPF app that I created for this. Now, if you're unfamiliar with WPF apps, what it is it's a desktop Windows app using XAML as a backend. And XAML actually we do have some WPF MVAs out there, and XAML MVAs. They've been some very good ones.
And I think you meant front end, right? It's the UI. WPF is the UI.
Right, the front end for it. The WPF is going to be the UI for what we're showing. And what we're going to be doing here is all the graphical work in this. So I made a window, and I made 2 list views. And I'm going to open up from the graphics here. I just made a grid with the list views. One is a player list, and one is data. And so that was my entire graphical information here for what I'm going to display on the server for right now. Now, could I add to the server here where I could click on the user and then disconnect them? Well, I could. We're not going to do that in this demo, but we could do those things. Now, on the back end, what I'm going to be doing here is I added a loaded function, and I am utilizing a library called Super WebSocket. Now, Super WebSocket is actually available in NuGet. So if you're not familiar with NuGet, you go to References, go to Manage NuGet Packages, and just search for Super WebSocket on the right-hand side here, and add it in. And what that does is provide you with a WebSocket server. Now, it also adds on the JSON and log4net as well. JSON for doing all of the serialization. So I am making a WebSocket server. I do a setup, and then I do add callbacks for a new session connected, a session closed, and one for data or new message received. And then I start the server. And on the unload function, I add a server.stop. So this way, when I shut it all down, it's going to shut down everything nicely, and the server will stop. Now, when I am getting data, and I had to do a little bit of changes into this one because being in WPF, it actually is, all of these messages are coming in at a different thread than the GUI.
Okay.
And in WPF, the thing is that you have to, anything you write out to the GUI, put it in a message box, anything of that nature has to be done in the GUI thread. You do not have permission if you're doing it from a separate thread. So to actually get this to display the different text that's coming in, I had to actually use a dispatcher invoke or begin invoke command. And if anyone who's familiar with WPF has done that in the past, this is the same kind of thing that's going to be utilized in Windows Store apps, Windows Phone apps, for a lot of the asynchronous things as well, because we get everything coming off of background threads. So looking at the message receive code, I am doing it inside of a begin invoke. Now, you'll notice that what I get from the message received is actually just a string. And what I have to do is that's going to be the JSON string that gets sent in. Now, I put in a few things here for construct 2, but I'm going to scroll down for a second to a login. So this section here for logging in. What I'm going to do is I'm going to use the JSON library to deserialize my login packet. So I had to make a login packet, and since we're just doing a simple sample here, I decided just to have a login name. Nothing else, just a login name. No password, no security, no hashing, because you're going to talk all about those things coming up.
Yep, we got a whole module on that.
Whole module on authentication and security, so I'm not going to bother with it in this one. So all it's going to be doing here, I deserialized that data packet into that format, and I'm listing it out saying that this person logged in. So if I start this up, I have my server here up and running, and nothing is showing up because I have no one logging in. So I'm going to launch a client, and we'll look at the client in a second as well. The client has a text box for me to be able to type in. Now, notice that it actually came up with a GUID here saying that this person was actually there. So a session started, a session was connected, and it added that code to my list. But if I come here and I do a login, and of course, the demos do not want us to go through this correctly.
The demo gods have struck early.
They have struck early. I always love it when we have demos that don't want to run while we're doing them live. So let me comment out the construct 2 code and start the server up again. Just gotta love it when demos do that. All right, start up our client again. And there's my server. So I have my GUID for the connection, and then I come into here and I log in, and it'll come in and say Steve logged in. If I have multiple or other ones come in, Brian, Michael. So we have all of the different ones, and I noticed here that Michael has now also connected over from the other machine.
I have.
And so Peter Rabbit has now logged in.
Yes, he has.
So apparently we got the demo samples working here.
You know what? Some of our gods are with us today.
Yes.
Oh.
The demos are working now a little bit better. Now, once I log off, I close mine, I'll notice that I do disconnect from here, and now Michael is still connected in. So this way, a small sample, I could add in chatting to this, I could add in all the source code, but I want to look at what the client is actually doing, because we look at the server code a little bit, and so there's one other thing we didn't look at in the server code, Michael, is we didn't look at what happens on the connected, a new session connected in. We looked at what data was sent in to add it to that list saying this person logged in, but we didn't take a look at where I showed that session ID.
Right, so I'm going to do that new session.
All right, so I'm going to come back into the code and notice that, again, there was 3 functions here for new session, session closed, and the receive. So I'm going to right click and go to the definition here. And all it's doing here is adding to my player list the actual session ID that got created. And if I scroll up a little bit, for the disconnect, for the close, I just removed that session ID from the list. Mm-hmm. So that way we're able to keep track of it. I could actually associate that session ID with a login. This person logged in from this session. So this way I could actually say, oh, well, this person changed their name, and keep track of all that logic.
So one of the things that we want to take a look at here too is that, behind the scenes, Super WebSockets is doing a lot of the legwork for us in doing our WebSocket connection, et cetera. So it's creating that session for us. So when the client starts up and initiates that initial connection, we'll take a look at this code in just a second. On the server side, it's receiving that connection request through TCP, and Super WebSockets is creating that session object for us and then firing that off to us through that event so that we can keep track of what's going on as far as new sessions or new clients connecting up. And then we get events for messages being received over those connections. So Super WebSockets is actually maintaining that session list for us, but there's nothing stopping us from grabbing that session data, putting it into some array or storage that we can hold on to and associating other data to it. For example, a user profile, their username, all that kind of good stuff.
And the nice thing is these packages, it's the Super WebSocket does give you the server code. It doesn't give you the client version though. Now right now we're not utilizing any of this stuff as being Azure specific. I'm running this locally here. But I want to quickly go over to my client applications code, and when it loads up, it does a connection to, right now that one's set up as localhost. Michael, you ran it with the IP address of my machine.
Yep, we shared secretly earlier.
Yes, and this way if it on open, on closed, on message received, I'm not having anything on any of those things right now, but when I press the login button, that WebSocket is actually doing a send of the serialized data packet, the login data packet. And if I come up to the definition of that code, as I said, I just wanted it to be the login. But I could have had it to be where it had a location information, anything else in that as well to be serialized down.
So is WebSocket included in the standard .NET libraries, or are we using another package there to give us WebSocket capabilities?
Well, there is, in the .NET 4.0 libraries, there is a WebSocket client. Not a server, but a client. Now, I am utilizing here a different one called WebSocket for Net. Now, the reason I utilized that one, and it was also a NuGet package. I'm running, the demo's running, so I can't go to the references right now. But the reason why I end up using WebSocket for Net is the fact that they do have a .NET 2 and .NET 3.5 version. And if anyone understands Unity, and we're going to talk about that after lunch, Unity actually uses .NET 2 based code and .NET 3.5 based code, not .NET 4. So yeah, we do have a WebSocket library in .NET 4 that we can use. But if your code is .NET 2, there are libraries that we can still utilize and talk about and use for our code.
Okay, so we're using WebSocket for Net because we get greater platform compatibility, right? So we get Unity, we get .NET, desktop, and we can even use it in Windows Phone apps.
Can even use it in Windows Phone apps. So we can utilize, and that's one of the reasons why you want to take a look at which packages that you are going to be utilizing. And so I made here another data packet, which is keeping a position, X and Y, and then a message. And later when we start doing some of our Construct 2 things, what's going to end up happening is we'll be connecting with Construct 2, jumping and moving around in the screen, playing our nice demo game, and we're going to be able to get all of that data back from to our server.
So is WebSocket for Net doing the right thing for us and making sure that even though we're passing through string, that it's actually using a string length and then the string itself and not a fixed length string to keep our packet sizes correct?
Well, one of the things that we can do to see that is inside of the code for receiving the message, I can actually have a breakpoint there. So if you send another login message or anything else, what it should do is give us the actual, yep, the server's still running.
Okay.
So it should come in here and give us the link to be able to do it and look at our string being sent in.
Okay, so I just logged in. There we go.
All right. So if I look at the actual string itself, login name is Michael.
Okay, so can you hit the magnifying glass and pull that open a little bit so we can see? There we go.
So that is the JSON for the actual login.
Nice.
No extra characters, no anything else of that. You do have the brackets and the the quotes on everything. So it is. So if you haven't dealt with JSON very much, it does look like, well, this could look a little smaller. But a lot of people end up using JSON instead of things like XML because XML looks a little bit more verbose than this. JSON now there's also a binary version of JSON. I'm not using that today because I want you to be able to read it. Obviously, if you're going into production, you're caring about how much data traffic. A binary version would shrink that even smaller because you wouldn't have a readable copy. So overall, that's the connection and that would be sent over to us, and then we're utilizing all of that for our connections. Obviously, you disconnected from our server while we're doing that.
I stopped my client side, so
okay.
I don't want to play with you anymore.
All right, that's okay. So, but if I look at the things saying like sending the data packets for moving our characters, I am going through a JSON deserializing of the object. Now, what's interesting with that is that it is doing string manipulation. It is actually slowing things down. String manipulation can be slower than just raw binary. A lot of times people will actually argue against using something like WebSockets because they go, things are slow, things are sluggish doing this kind of thing because it's all text-based. Well, like I said, you can use the binary JSON for doing the communication instead. It just makes it harder to demo live to you like this. Now, if you are worried, a lot of people like using TCP and UDP. And what we have to do those in that case is actually look at the stream of data that we got in and do some interpretation and read and start reading bytes of data to say, oh, this is this kind of a packet. And that's one of the things that I've had to do with some samples. Now, we're going to be putting up all of these things into a GitHub repository. We had a small hiccup creating it earlier, so we'll create it later before the end of the day and put that up. But we'll have all the sample code and available in a GitHub repository for everyone, as well as some samples that I have done using things like C++, TCP, and UDP communication as well, and being able to look at those projects and those samples.
Right. So to get back to that argument that was made about using JSON for data, right, and it's slow and sluggish, this goes back to the idea of knowing what you're sending out and knowing how you're working with your packets. One of the things that you want to take a look at is as you're sending this data, knowing that everything is going through as strings, where can you eliminate those strings? Where can we change that from being, the word login or the, some type of action that you're trying to portray, and turn that into a number, turn that into something smaller, right? Instead of sending large amounts of strings, eliminate those things and convert them into things that the computer can understand really well and translate really well, which is numeric data, right? Really good at that. So any place where you can eliminate strings and eliminate string comparisons, you're just going to speed up your game innumerably, right? So as long as you can get back to that number, and that number is well-known, well-defined, then it's great. The only problem with that I've ever seen is that sometimes moving and adding things can take a little bit of time, but that's on us. That's on us as a developer, not on the user. So anything that we can do to make our users' experience and our gameplay even better, always a good thing.
Well, and by looking at the one thing that we're going to also see with WebSockets is that we have our string of our JSON, and we have to deserialize it, and it might be actually more beneficial to deserialize it into something like an anonymous class, to where it's not a fixed format. Because if it is a fixed format, my login is different than my position data structure. So what I have to do is I have to deserialize my string in both of those formats and find out, is it login or is it position data? I think that's also where some of the sluggishness and some of the concerns on timing are, because if you are going to have to deserialize this multiple ways to figure out what data type it is, that can be very sluggish.
True.
But of course, again, you want to separate your concerns. I'm going to be pulling in this data. I might want to add it to a queue for the rest of my system to utilize, instead of having it sit there and wait for me to finish processing it before I do something else.
Okay. So this sample is great, Steve. I like it. I think everybody that's watching is also like, hey, this is cool. We're finally getting into some code. But how does this relate to Azure? I mean, right now it's you and I, but we're on desktops. How can we scale this out so that, we could have a chat server that's going to be, we could involve lots of people into this and getting started and building our awesome game?
Well, and that's the thing, is that when you have a virtual machine, it is the same thing as having just a normal desktop. And now, of course, if you are running it as a Windows server, you need to make sure to take special care in how it's configured, firewalls, things of that nature. But it's just like you're running on your own desktop. So I'm going to actually switch over to, I did do a remote over to the virtual machine that we created earlier. So this is the virtual machine.
Yeah, I can see the host name is WSS. I remember that's what you named it.
WSS here for the host, and the public IP address. Oh wait, other people can connect to it now. Oh, that's okay.
They don't have the code, we do.
They don't have our sample code.
Yep.
So we do have the public IP address right there. Now, when I did a remote desktop over to this, I actually added my local drives here. So I could take some code from my local drive, compile it, bring it onto the machine, and being able to run the server code that we had running earlier on my desktop on the virtual machine in Azure. So I now have this.
So it looks the same as what we saw on your desktop.
Exactly the same. Now, a couple things to worry about with this, though, is that I do need to come in when I'm creating this on the website. Before I start it up, I do need to go to my settings and make sure I set my endpoints.
Endpoints?
Well, the endpoints are what's going to allow us to say, this is the open port. This is the port that I'm doing. If you set up a Minecraft server or any other server, you actually get used to saying, I have to open up my own firewall, my own router to these endpoints, these ports. And so what you have to do is we have to go through this and add the endpoint that people are going to connect through. So when I added this, I added the MVA WebSocket. It is a TCP protocol. When you add a new one, you can add a TCP or a UDP. And WebSockets actually operates over TCP.
Okay.
So I made it as TCP, and it was port 2012. So I had to make sure to add that in first.
Okay, so that basically enables our server to talk to the outside world, right? So we're opening up that port so that when it connects, it doesn't get a failure notice, and when your client tries to connect, it's not going to stop it. So it's essentially opening up a hole in the firewall of Azure, right?
Correct.
Sounds scary.
Well, that's the thing, is that you are opening up the firewall, but how many times have you... my son actually got very good at My younger son got very good at actually opening up the ports on our firewall and on our routers to play Minecraft and everything else on. So this is something that a lot of the kids and a lot of the people playing games are very used to being able to do. It's just that we're opening it up on this virtual machine.
All right. You just open up only the ports that you need. Don't go and open up, all ports, right? So that's the lesson there, is that you just open up the ones you need, and that way you can keep your server secure and, decrease the surface area for, malicious people to try and get in. So are we ready to connect?
Well, try and connect over, and I think we might see a different problem if you try and go and connect over to it. This is actually the Server Manager portal that comes up with Windows Server. And one of the things is I think that the firewall is still running on the local machine. Firewall is on.
Ooh, okay. So I launched mine, but do we see it show up on?
You launched yours, and I'm not seeing the connection.
Yep.
Because my firewall has blocked it.
Okay.
So what I'm going to do in this case is I'm going to actually disconnect my firewall here.
Okay.
And of course, I am so not used to Windows Server, turning off my firewall here. Turn firewall on and off.
There we go.
Turn it off. Now, obviously, we really would open up the ports through the firewall, but this is a faster way of doing it.
Okay. So I think you're going to have to restart that.
I think I'm going to have to restart the sample.
All right, just to be sure. Okay, I'm going to restart my client. And there we go.
And you connected?
Right. I'm connected, and let me log in. Let's see here. Who am I going to be today? I think I spelled that right. Oops. And
I had copied this over earlier, and so the what crashed on my local machine is not up there. But we actually saw the connection. We did get the connection back.
We got that data because we got the exception, so that was good. I mean,
we did get the exception. You did crash the server on me, so I mean that. Now the nice thing is that you can run instances of virtual machines with Visual Studio already installed on them if you have an MSDN account. So you can start up and choose one that has Visual Studio 2013 or 2015. So you can do bug fixes. You don't have to do them locally and then copy the code over. You can be running and debugging on your virtual machine in Azure. But that actually worked well by having that firewall turned off. I wanted to make sure to show the turning off of the firewall for that, because that is one thing that a lot of people forget, is we're in a society where we have firewalls, and all of our operating systems have firewalls to protect us and protect our servers. And you don't really want to open it up to everything like we just did in the sample.
Yeah, definitely shrink it down to just the holes that you need, and going in and making sure that, on the Azure side, you've opened up the right port, and then in your server firewall settings that you've opened up the right ports to allow data traffic to go through as well. Line them up so that your server stays secure.
And that way also, I mean, like I said, we ran the app and everything ran just like it was local on the machine that we were running to begin with.
Yeah.
And we really didn't put into that app, that demo, we didn't put any special Azure code. There was no Azure special sauce there.
No. It was just running in a VM, which we own, or you own, right?
Yes.
So we just copied the code up there and just ran it. Awesome. Very simple.
Well, and the nice thing is that especially that I've seen students, when they're making their servers, they're making their machines, they're used to running it locally here, running it on their laptops, running it on their desktops, and doing it and scaling it to their friends. But by having it to where I can just instantly put it up on Azure, the exact same code that I ran locally here, that's really handy, because now I have a local test platform for it, as well as having it up in the cloud. Now, one thing, since I just copied over the executable and ran it over there, I didn't put anything in source control or things of that nature. But that is, I think, a very important thing to make sure that we utilize and everyone utilizes for that. Mm-hmm. Because I have seen so many people, a good friend of ours, she was actually doing a live demo online Tara Walker, and she had her demo working perfectly and forgot to put it in source control, and then her hard drive crashed. And she had to rewrite everything from scratch, which you don't really want to do.
Unfortunate scenario.
Unfortunate, but not uncommon.
No, unfortunately, very common when we talk about individual developers, et cetera, who don't think they need source control. So it's definitely something you want to leverage as early as possible. And I believe there's a service in Azure that can help with that.
Yeah, Visual Studio Online does support that. And by having Visual Studio Online, it does support Git formats for doing things like Xcode or Eclipse and tying those in. So if you are doing iOS apps or Android native apps, you can utilize those as well. And I like that because I have, on my own account, I have like 40 plus projects on my Visual Studio Online account. Now, what I can also do then is right from the server, I could then pull it down locally. So I could have a build environment there, I could have a compiler there, and all of those different things with running my code up in a virtual machine in Azure. So that was a nice little sample for our chatting, or for our communication and being able to go back and forth.
Yeah.
Now, afterwards, we intentionally didn't put any security in right now.
Yeah. It's demo code.
It's demo code, but you're going to talk about some of that in the next coming up after our food break.
Yeah, after our meal break, we're going to come back and we're going to talk about authentication. We're going to get into using some more of the Azure services. So stay tuned, come back and join us in about an hour, and we'll get into some deeper topics.
All right. Thanks very much, guys. And welcome back after lunch. Hopefully you had something good.
Or dinner. Depends on the time zone they're in.
Or dinner. Could be breakfast too.
Yeah.
All right. So
I hope they ate, because we got more content to go through.
We've got a lot more content to go through. And the thing is like we said earlier, we had a lot of our demos we were setting up as simple, easy things to where there was no authentication, no passwords, just easy things for demos. Well, we can't leave you with just the easy things. So Michael's going to kick us off now with some authentication.
Yeah, so we're going to talk about authentication and go through a few different aspects of, what is authentication? What does it mean? So we've got what is authentication. We're going to take a look at some of the options that we have in Azure specifically for performing authentication. So while we could do authentication on our own, we'll talk about that. We're going to go through authentication and also the concept of authorization and how they work, so we understand what we're doing when we're actually going through and making some of these calls. And then we're going to take a look at, how do we take our game assets and secure it using authentication and authorization. So what is authentication? It's the age-old question of who are you, right? So how is it that we're going to figure out whether or not you are who you say you are, and who's going to validate that and ensure that you are indeed this particular entity. So to get into this whole thing, let's take a look at some definitions of some of the concepts that we have in authentication. The first one is identity, right? Really big concept here of, who is it that we're looking at? Who is it that we're communicating with, and ensuring that this entity, this identity is valid. And that process of doing that is authentication. So we have this identity, and then we have authentication going through and making sure that you are who you say you are by validating certain claims that you make as to you are that person. And claims can be as simple as what your username is and what your password is. Or it may include other forms of identification as well. You could have two-factor authentication with not only am I supplying a username or password, but I've got this little dongle thing that has a number on it that sequentially increments or randomly changes, and I've got to supply that as well, and so it's almost a time factor in here, and this kind of thing. Steve?
Yeah, my bank actually does that for their website, and they'll actually text me a message to say, "Hey, are you actually trying to get to the website and get you into your account?" And I think, Azure does have that kind of support to do that multi-factor authentication and texting people and stuff.
It does, and today we're going to keep it a little bit simpler. We're just going to deal with, a couple of different identity providers and work with them to, validate that, you are who you say you are and get that information and be able to grant access to some stuff and keep it in the gaming context. So we've got identity, we've got authorization, or authentication, and then we have authorization. So authorization is this last piece of it that happens after you've authenticated. Now we've got a relationship. You've said who you are, and I validated that with some authority to say that you are this identity. And now what we can do is say, all right, since I know who you are and I know who everybody else is, let me group everybody up into discrete blocks and be able to restrict access to resources based on that information, that grouping of data. And so we have the authorization. Authorization is that check of I have this resource and I have this identity, and I need to make sure that this identity has access to this resource and ensure that you're only getting access to the resources that you are supposed to have access to and not the ones that you're not supposed to have access to. So really simple, yes or no. So with authorization and resources, right? It's a very vague term of resources. What are resources? This is anything that's in your game, whether it's game logic or it could be assets inside of the game. Maybe you're working on a subscription model and you have certain features or assets, artwork, etc., that's only available to people who have paid the extra price in order to get access to that. So you can use identity and authorization and access control to secure access to those resources, to those assets, game assets, and make sure that, people are getting their money's worth. All right. So what do we have as options in Azure for being able to perform authentication and authorization and those kinds of good stuff? So what we have is we can classify it into two different sections for Azure. One is server managed. And this idea is that all of the authentication is going to happen in Azure, and we don't need to deal with a whole lot of the work involved in working with the identity and access control and authorization on the client side. And this is going to push stuff up to the server. This is a good way to operate when you're working with a large number of clients. If you really get into the security of stuff, one of the first things you're going to want to do in developing your games is work with the mindset that you do not trust the client. Right? Because it can get hacked. Somebody could, whether it's on the desktop or something like that, they could decompile your project, figure it out, modify it, and then rebuild it and start playing with it and, basically hacking your game and being able to get exploits and cheats, etc. So if you don't trust your client, then you're looking at the mindset that anything can be done on that client. So I want to pull as much up to the server and restrict it in that fashion. That's what server managed authentication is going to do for us. It's going to pull as much as we can up to the server side and eliminate any type of interference from modified client stuff.
So like with the example I gave earlier to where I modified the script to actually do a huge explosion in the game, that I couldn't do because you would probably send up a message saying, oh, I used this ability or skill, and then the server would do all the rest.
Absolutely. Yep. So we're going to keep that to a minimum. In the terms of authentication, what that means in Azure is that we're going to use what they call identity providers. So this allows us to integrate into your authentication mechanism different providers that ensure somebody's identity. All right. So let's get specific. What does that mean? It means we could use Facebook login, we could use Google login, the Microsoft account login, or you could even use Active Directory hosted in Azure and create your own accounts. One of the things that I really enjoy about working with the access control in Azure is that I'm now no longer responsible for storing passwords. Right? So I get out of that whole aspect of, I have somebody's password, which they may or may not use in other sites, right? So, raise your hands, right? How many people use the same password on multiple sites, right? Yay! Not a good idea, but people do it because it's hard to remember passwords. So if I can get out of that business of having a password stored in my database, whether it's up in Azure or on my machine, love to get out of that. Don't need it, don't want it. Let's use a different identity provider and let them do what they do best, which is to authenticate somebody's identity, and they can keep all of the security measures, et cetera, in place for doing that authentication. So the flip side of it is to do authentication with the client side, do it client managed. In this way, what we're going to do is we're going to use a library called Live Connect, and Live Connect is available on a bunch of different platforms. But in this case, Live Connect gets installed as part of your application. So a lot of security and a lot of the mechanisms for authenticating somebody is going to be done on the client side, not on the server side. So you can see a big difference in the workflows as you work through a server-managed versus client-managed authentication process, because on the server-managed side, we're going to throw up a login page that's actually driven by Facebook or Microsoft account, and you're going to log in directly into that site. Whereas on the client-managed, not necessarily going to get that. It's going to be managed on the client. You're going to have to provide your own UI. Cool parts about this in Azure is that we can actually leverage multiple identities or identity providers so that your game could actually accept Facebook and Google and Microsoft account, and then also have a set of Active Directory accounts that you use for things like administrative or some super user type of accounts inside of your game. All right, so now, once we've got that good stuff down, we know what our identity providers, we're going to make the decision as to whether or not we're going to go server managed or client managed. We need to know how authorization and authentication actually flow and what's the process of getting access to these resources. So with authentication, it starts out on your client. And your client is going to launch the game. All right, so we launched our game, the game screen comes up, and if you've got any type of personalization in your game, or you're tracking things like leaderboards or profiles, saved games, all that kind of good stuff, you're gonna need to have somebody sign into your game. So, you have a sign in button on there, or maybe that's the first screen that pops up, is someplace for the user to sign in. And you'll have to provide a UI, such as, I want to do my Facebook login, I want to use a Google login or Microsoft account. And once they choose that, click the sign in button, we then send this request onto, and in our case, I'm going to leverage Azure Mobile Services, right? So that's going to be the next chunk that receives this request. We're going to make a call out to Azure Mobile Services because it integrates really well into our authentication systems. And these game services, this is my game, right? We're going to try and sign in. And the first thing it's going to say is, look, I don't do authentication. Azure Mobile Service, no, I'm going to pass that off. And I'm going to pass it off to whatever is configured as the identity provider. So we could have multiple identity providers set up. So you could do the Facebook, you could do the Microsoft account, et cetera. And when the request is made, we're going to specify what type of a login we want to do. So, we've chosen Facebook authentication. So we pass that off to the Facebook identity provider. They're then going to send back the UI for logging into Facebook. So you're actually going to see the branded site for Facebook. Your user is going to log in using their Facebook information. That doesn't go to the Azure Mobile Services or anything. It goes directly to Facebook. We're not involved in that at all. We're just projecting that UI into our game. Once they've supplied their credentials and click the sign in button and Facebook or Google or the Microsoft account's all done, it's going to send back to us that authentication token, right? So now we know, yes, we've authenticated, we're good. Otherwise, we're going to get an error, right? So we can check that as well and be able to loop through and say, hey, look, you can't move on until you've gotten fully authenticated. So the authentication token comes back to mobile services. And depending upon where we're starting out with authentication, in this case, if we're just doing sign-in, then that authentication token is just going to get passed right back to our game, and essentially we're logged in. And now my client can use that authentication token for additional requests. So one thing to think about, though, is that if you're going to use a sign-in every single time, you're making this call back to the identity provider, right? So I sign in, make the call to identity provider, get that authorization token. Make a sign in, make the call to identity provider, and get the authorization token. We can eliminate some of these calls to the identity provider between times when your game is started and stopped, right? By keeping track of that on the mobile services side and caching that data into the Azure caching service, either Azure Cache Service or Redis Cache, right? So now when the sign-in comes in, we can say, hey, wait, do I have a cache set of credentials from this particular device? If so, return that as the authorization token instead of making a call to identity provider. This is going to be a lot faster. You're going to save some cycles here and speed up getting your user back into their game and playing again. So now we've got a great way of optimizing this just a little bit. You're going to need to check, of course, once you get back that cache token, that it's still valid. Right? So you want to make sure that it hasn't expired, because the token will have an expiry date or in time, essentially. So you want to make sure that that's still good, and reissue it by going back and doing another sign-in to the identity provider if it's bad.
So this overall kind of caching it kind of gives you almost like a single sign-on type of thing, to where you needed to sign on one time instead of every single time you logged in, because people don't really want to put their passwords in. Oh, wait, I need to shut it down. Oh, let me go back into it. No, let me shut it down. And putting password in every time would be, I don't think anyone will play your game anymore.
Nah, it's going to be really, really painful to do that. So yeah, this does some sort of single sign-on. We've got a couple other things that we're going to talk about with single sign-on as well. All right, so the next step after you get signed in, and you're authorized, you've got your token, now you need to be able to get stuff out of your game service. So we're going to go through the authorization process, which again starts at your game, and you're going to make the request to the Azure Mobile Services, right? So this request could be for something simple like, and I'm going to use this example many, many times, of a leaderboard, right? So I only want the leaderboard to be accessible by players who are signed into my game. So I don't want to project the leaderboard out for just everybody. Okay, so when my game requests the leaderboard, the user taps on the leaderboard button or whatever it is to initiate that initial display. We're going to make the request out to Azure Mobile Services and say, hey, get the leaderboard. All right, and with that, I'm going to pass the authentication token. And this token says that, hey, this is my identity. And we've already gotten that from the authorization process. So I'm holding on to that right now. I'm just going to send it through. So on the Azure Mobile Services side, it's going to accept that token and process the request. And that can either be for getting the items or not, and it's going to validate that this token has access to those particular resources. All right. So it could do that by going to the Azure Cache service, right? Making sure that those are still valid. Do I have it? Yes. Pull it back. Okay. And if it's not valid, then it can automatically go to the identity provider and force the user to sign in. Right? So if the client has sat there too long, your game is just sitting there. Let's say, for instance, the user locked their phone with your game running as the top app. So now, in this case, the cache token is expired. So we're going to use the identity provider to go get a new authorization token. Whoops, wrong way. And send that back to the mobile services. Now I've got a valid authorization token, and I'm going to send back to the game. I'm going to send that, hey, yeah, this process, this call was a success, and also send back, if it is a updated authorization token, they're going to get the updated authorization token with a new expiration date and the results of the call. So they'll get the leaderboard. Now, let's make this even better here, right? So one of the problems that you're going to run into is this authentication token expiry type thing, and the possibility of having to sign in multiple times. So what we can do is we can actually store that authentication token on the client side too. This enables us to do a much better single sign-on than we had with the authorization set up before. So essentially, once we get a valid authorization token back, we can use a password vault on the client side, or something like a certificate store or whatever, to take that authorization token, put it into a secure storage location, because this is identity, right? We want to keep it safe and secret. And there's lots of movie references I have going through my head right now. But Password Vault is one of those pieces that we can use to secure that authentication. And so only our application has access to it. And now when the user leaves my application, my game, because they're done with their turn, that's fine, all right? They're going to exit, they're going to go read email or possibly play another game. When they come back to my game, I can open up the Password Vault, pull out that stored set of credentials, and pass that onto my my service instead of having to do another sign-in. So my flow for my application changes on startup from, open up, give the user the sign-in page that they then click sign in and go through the whole process, to, hey, do I have do I have a stored set of credentials? Oh, I do. Great, let's use that. And only provide the sign-in page if the set of credentials has expired. Make sense? I think so. It's not that bad. In fact, it's really interesting how close the authorization and the authentication flows really are. So the next step is, how do we go and secure our game assets? And now let's get into some specifics, right? We're going to be dealing with Azure, and we're going to do it with Azure Mobile Services and the authentication components here. So one of the first things is that we need to register our game for authentication, right? So in game here, we're actually talking game service, so we're dealing with things up on Azure. So we're going to register for authentication, make sure that we've configured identity providers. We're going to then take a look at our game services and add in restrictions to make sure that only authenticated users have access to those calls, right? So we can only get that particular data. And then we're going to go through and we're going to add authentication to the game. So we're going to take a look at how to add it in there. And we're going to take a look at some special scenarios, like cache authentication token on the client and handling expired tokens. So all that stuff that we're just talking through with the slides, we're going to see how that actually works in some code. And if everything works right, then it's all going to go well. So in the Azure portal, this is where you're going to register your game for authentication. So when you're going through and creating your mobile service, you'll go through and you're going to set up some properties to say, hey, I want to have an identity provider. And I want to be able to authenticate that against some specific identity provider, like Facebook or Google or whatever, and be able to provide those authentication tokens back to your game client. All right, this part's pretty easy. There's just a couple of steps. The hardest part about this whole process is actually setting up the identity provider. You're going to have to do that for each individual identity provider. So you'll have to go and set up an app in Facebook for login. You'll have to do the same thing for Google app authentication. You'll do the same thing for Microsoft account authentication. And if you're creating an Active Directory setup for it in Azure, you'll do it for Active Directory. And usually it's 2 or 3 pieces of information that they require in order for your app to get connected to these identity providers. It's usually an API key and a secret, right? So that we can make that connection as an application to those identity providers and allow them to send the data to us. All right. Once you've got that, you then need to restrict access to certain resources on your application. So, for instance, I have a function to go and get or return the leaderboard, right? Which is a list of every user and what their score is, right? So on that call, on my service, I need to be able to say, hey, I only want authenticated users to have access to this web call, this web API call. So in .NET and Azure, in the web API, all we need to do is put a simple little attribute on the method call that says, hey, the authorized level for this is user. So it requires authentication instead of being anonymous and allowing anybody to get access to it. You could add this attribute, this authorized level attribute with authorization level.user at either the class level. So that would restrict all of the methods within the class instead of just a single one. Or you can put it on each individual method. And this way you can configure what the authorization levels are for each method independently. So you can do the whole class as a whole, or you can override and set specific methods.
Now, Michael, on all of these setups and the things we're explaining here, there's 2 ways of making mobile services currently, doing a JavaScript backend one and a .NET backend. Now, can you do the same thing on both?
I haven't tried with the JavaScript. I'm strictly doing it in C#, but I believe the ability is there, but I'd have to look that one up myself.
I would think that all the abilities are there. I've
actually, you know what? I'm mistaken. I do know that it is there. It's just done a little differently. You don't use an attribute for it inside of your JavaScript. Instead, it's done outside in the portal. You go through, set what the access levels are.
But then the people comfortable with JavaScript or .NET could do either way.
Sure. Yep. So one of the other things that you want to be able to do too is test out all this stuff locally before you have to push it up, because deploying to the server, although it's not that much of a hassle, it's time consuming, right? Every time you have to publish and then test, etc. It does take a little bit of time. So you can debug these things locally. And the way to do it is to add into your app.xaml.cs is a config.setIsHosted and pass true. And this will allow you to test the permissions locally. So it essentially acts as if it's got a Active Directory authentication behind the scenes for you. All right. And we'll take a look at where to put that in. So once you've set up on your server side, you've got authentication, all right, and you're setting up what the authorization levels are. The next step is to come into your game and say, okay, now let's configure up authorization. So I want to do a sign-in page and then be able to request resources that are secured for only authenticated users. So to request authentication, it's actually just one line of code to do this, to get the user back with the identity providers and using a server-managed setup. So, we have this idea of a mobile service user, and this is given to us from the Azure Mobile SDK. So if you're using that, it's really easy to do this. If you're writing it all yourself, it's just all a whole bunch of REST API stuff, but it's still just one function call or one REST API call to get the user. And this is a C# code, so we're using the mobile service user, and we're going to assign that to the result of a login async method. So since it's async, we await it so that we don't move past this point without a user. And we pass in what the mobile service authentication provider is. And in this case, the sample, it's .facebook. You can replace this with .microsoft account, .google, .active directory, etc. They're all in the enumeration here for us. So this will actually then launch the UI for the identity provider to, for the user to type in their username or password or whatever the authentication is for that provider and get back the mobile service user. And again, as I said, this is inside of the mobile service SDK, so you get this kind of stuff for free. There is one gotcha in the Windows Phone. It does require us to handle this response that comes back. So the user, you have to use it from the web authentication broker inside of the unactivated event of our application page, right? So in the unactivated event, you're going to get a message. It's going to be from the web authentication broker. You have to handle that, and then you can get your user out of there. So it just comes back a little bit differently than doing the await.login async. So just a slight little one in there. We also have this idea inside of Windows Store apps that we can, and this is phone or Windows desktop, that we can have single sign-on, and we can pass in as the second attribute into the login async method that's up above. Just pass in true, right? So when you call login async, you pass in what is my identity provider, comma true, to say, yeah, I want to do single sign-on. And this is going to force the Windows apps to cache that credential. So this is a cheap way of getting single sign-on. But this is only true for Windows Store apps. So if you're not in a Windows Store app, you're going to have to do it yourself. All right. So to cache the authentication token on our clients, so a standard sign-in, right, which is what I'm calling it here, right, requires your client just to go out and contact both the identity providers and your application service, your game service, every start. And we talked about this a couple of slides ago. So we want to be able to eliminate that. So once authenticated, store that token in a password vault. If the token is expired and we get a special HTTP result back, and that's unauthorized, right, because the token's expired, so we're not going to have access to it, then we can simply request a new token. Essentially, that follows the authentication process again, logging us back in again. So handling expired token, inside of store apps, we can use something called the delegating handler, and this allows us to set up a class that can act as a go-between between the identity provider and the rest of our code and automatically handle things like the unauthorized result that comes back and force a login and then send the request header again. And so this does it automatically. There's a little bit of code that we have to set up to get this to work correctly, but it's not extremely involved, and you do it once and it's pretty much the same every time after that. One of the tricks to it is that, because the request could be sent multiple times, at least twice, you're going to send it initially to actually do the request, but if you get a 401 authorized, then you're going to have to, re-log in. When you come back, send the request again so that the user doesn't have to, hit the same button twice. You're going to have to send the request header again, and because the request can only be written once, we have to clone it, write it over, and then send it again. So you can't modify it after it's been sent. All right. So this now takes us to the part where we get to open up Visual Studio again and get into some code.
It's always good because sitting here just watching slides and talking about them, sometimes We might have to wake the people up after lunch.
Yeah. I was starting to put myself asleep with those slides. No, just kidding. This is exciting stuff. I love authentication, authorization, security type stuff. So I've got a sample set up here, and I got Visual Studio open, and I've got this main page here, and it's a very simple main page. I kept this whole thing simple just to show how we are working with authorization and authentication. So it's simply a Windows Store app, and I've got a really small button down here, which I can make bigger. All right. And so I made the button bigger, but I didn't make the text bigger. Well, it says sign in. And what we can do is when we click on this button, it'll launch our authentication process, force us to log in, and then get back a leaderboard. And that's what's going to be displayed in this list view up above. So very simple app, very simple process just to show us how we're going to get from point A to point B. I have a service set up. So I've got this game service here, and this manages my leaderboard. And I have a class here in my data objects that's a leaderboard item. And because all of our web API stuff, when we're dealing with Azure, we get Entity Framework for free in this. So we're deriving everything from entity data. And I've just got two attributes on my leaderboard item. It's a user ID, or actually members. It's not an attribute on the class. I've got a user ID and a score, and they're set up as public properties with the get and set methods, right? Very simple, don't need anything in there unless I was going to add some additional logic. I have a leaderboard controller in my service as well. So here's my leaderboard controller class. It derives from table controller and is a table controller of leaderboard items, right? And this is pretty much boilerplate code that was provided right out of the box for the Azure Web API solution, which I'm going to go through the step in just a second. But I've got my get all leaderboard items method here that I've already gone through and added the attribute to authorize that level at the authorization level.user. Now I can take a look and say, well, what are the other authorization levels that I have? So we have admin, anonymous, application, and user, right? So any of these authorization levels, admin being only administrative level users can have access to this method. Anonymous is anybody. Application is the application can access this API. We don't have to have a specific user. It's just the whole application is authorized. Or I have to have an authorized user, okay? So I've attached that to there so that we can test out our authorization. And so that's the extent of my service, right? It's just these things. And I'm preceding the table with some items so that we can get something back. In the client, so I've got my my game client up here, which has a Windows and a Windows Phone version. I'm just going to play with the Windows version for today. I've also have a leaderboard item in my data model over here, but it is slightly different for mobile services because we're going to get this ID attribute for free. Once you've inserted items into the table in the mobile services, it now has an ID attribute, and when it sends it back, it's going to expect that. So you can't just copy paste your models. You have to add this ID attribute in there to pull that back. So I've got that in there. And then in my my actual window code, all right, so in the XAML CS, I've got my page. And I've set up a couple of defines because I got 3 different scenarios I want to show you. But at the top, I've got a couple of convenience properties that I've set up. One for the mobile service user and one for the mobile service client. And the difference between these is the mobile service client is what's actually making the service calls back into the web API to do things like get all leaderboard items, right? And then the mobile service user is what we get back when we make a call to log in async. Okay. So I have set up an event handler on that login button that's attached to sign and click, and it's going to await and authenticate async. Okay, so it's just going to go through and do the authentication. We then have just a simple statement here that just hides that sign in button, and then a function that will go out and refresh my leaderboard, pulling back that data. So for the first step, I just want to show you a really simple way of handling authentication. So as long as my user is null, right? So in this case, the user accidentally really clicks the button fast, and we get a couple of these calls in here, we can prevent that from happening. So while the user is null, and we can also, since this is a while, this is going to occur as long as the user doesn't cancel the authentication. So this is forcing our user to authenticate to get to our leaderboard. So what we come in here is we hit the user and we say, await the mobile service. So this is my mobile service class. I'm going to call login async on that, and I'm just providing in Facebook authentication. So in my particular example right now, just doing Facebook. Okay. And if that works, then we're going back and we're just going to tell the user that, hey, look, you're signed in now as this particular user ID. If it fails for whatever reason, we'll get an invalid operation exception, and our message will be that we must log in. Login is required. From there, we can create our client, because now I have the application URI and the application key that are necessary for me to talk to the service. And once I've set this is actually going to get used by the refresh leaderboard items, which occurs a little later. So, and that's actually down here towards the bottom. So here's my refresh leaderboard function. So after we authenticate, we come down here. We're going to use the client. We're going to get the table of leaderboard item, and I'm just going to grab the top 3, convert it to a list of enumerables, cache that into an items, and then set that as the item source on the leaderboard list view user control, right? Or control, so that we can see what these items are. So it's really simple. I'm not doing a whole lot up here as far as any type of ensuring that the token is valid, et cetera. This is just going to force us to log in every single time and get access to these resources. So in order to get all this to work, I've got to have an Azure mobile service. So now I can go to our Azure dashboard, and I'm using the older style dashboard instead of the new one. I'm a little bit more familiar with it, and I can get it to work most times. So we haven't created a mobile service yet, so this is right out of the gate. So I'm going to create a new mobile service.
And this portal actually does have the ability to zoom in nicely, which is something that the new one doesn't have the ability. So I love my touchscreen on my tablet, and I will constantly just touch and expand. But on the new portal, I can't. But on the old one, I believe it should work fine.
Yeah. So I just expanded it so you guys can see it. So I need to provide a URL. So in this case, I'm just going to call it game service, all right? And it will, somebody's already using that, all right? So game service underscore MVA.
And someone has that one as well.
No, that says it must contain only letters, numbers, hyphens. Oh, so I can put a hyphen. So dash MVA, there we go. Remember my internet naming schemes, right? So game service dash MVA, got the green check, we're good. I'm going to create a free 20 meg SQL database as the backend storage for my mobile service. I'm going to do it in the West. And my backend, I'm not going to do JavaScript, I want to do .NET. So I'm going to say, choose the .NET and click my arrow to move to the next step. And it's going to say, hey, what do you want for a database? So game service dash MVA underscore DB, that's good. And I'll create a new database server. And we'll use game server underscore dash MVA, keep things consistent here. And the password, keep it secret, keep it safe.
You're not going to share with everyone?
I am not going to share with everyone because I want it to work for the first time out. So I'm not going to configure any advanced database settings. And this is one thing I like about mobile services is that, with just a couple of fields, I'm getting a full mobile service and, click my checkbox, and now I'm just waiting a few minutes for it to finish building this out. So Azure makes this really simple to set this up, get it going, and within a couple of minutes, I'm going to be able to publish my game service up there and be able to attach to it from our client.
Now, one of the things you mentioned earlier is that you need to be able to trust the identity provider. Facebook, I mean, as we all know, people make lots of Facebook accounts or Twitter and things of that nature.
Sure.
Now, obviously, for a game, I think any of those would be perfectly fine. Banking, not the best scenario. But I actually had made a mobile service using Facebook because it was an app that was targeting teens.
Sure.
So targeting teens, Facebook was a perfect choice for that. Whereas if, like, I was trying to do a corporate website or a corporate app, then doing something tying to an Azure Active Directory might be a better choice.
Sure. Where you have a little bit more control over, what users are getting created, et cetera, and you're in charge of that authentication store. And like I said, it all depends on how you want to get into, managing passwords and having that type of secure data and sensitive data, really. So you want to keep track of that. So it's already done. I think that took under 2 minutes to get it ready. So now I can just select my mobile service, and it's going to launch me into the dashboard. And right off the bat, and I love this about the mobile services, is that right underneath the dashboard is a getting started section. We can choose our platform, whether we're based on Windows, iOS, Android, HTML, JavaScript, or if you're going to do Xamarin for iOS and Android, right? So iOS and Android here are native iOS and native Android versus using Xamarin, which is C# on iOS and Android. You choose your platform, and then you can either create a new app based on that platform or connect an existing one to that platform. It gives you step-by-step instructions on exactly what you need to do in order to get ready to publish your mobile app. So you can just follow these steps and go. And even better, it has download. You just download the existing project. So it sets it all up for you. It's connected to your mobile service. You can just use this as a starting point to get going building your game.
So on my iOS app that I might have, I wrote in Swift, I can connect perfectly fine.
Sure.
Or
even from Objective-C.
And then there's sample code for that.
Yes, there's sample code for that. Yeah, you just download it. It's all templated and built out. You just click the buttons and click download, and then sends it down to you.
And the second one where it actually says add it to an existing, that'll give me all the steps, right?
That'll give you the steps to hook in your existing project into this mobile service. So you can create the mobile service and then download a pre-set up application, or you just follow the steps to hook it in. Yep.
Nice.
So and I've got the website set up so that I've chosen iOS, and I can create a new iOS app, and it tells me, okay, well, here's what you need to install. On the PC, Visual Studio, and then hey, you need a Mac, you need Xcode, and then you can download and publish it, and then you can choose your languages, Objective-C or Swift, and download that app, and on your Mac and launch it against the service. It's just going to work.
Nice.
Yeah, nice. Like it. Okay, so the next step we need to do is go configure identity. So we've got the Microsoft account settings, the Facebook settings, and the Twitter settings. So the first thing I need to do is, since I want to set up Facebook, I need to go get my app ID and API key. And this is the one thing that I didn't tag out initially. So I've got to go and log into Facebook here, since I set up this earlier.
Now, I've done a few mobile services, like I said, and the driving app I did for teenagers using Facebook, I had set up against all of the different accounts because I was like, why should I limit it to just Facebook? The problem is that some of the instructions in some of the services are very difficult and very demanding as to what they request when you set up. They actually would like a detailed description, a website, a icon to link it in, so they do get very tricky sometimes when you're setting it up.
Yeah, it can get a little tricky, but it usually doesn't take too long to go and get that.
No.
So I just have to remember where to go get. It's under settings, and then I can go to apps, and yeah, I don't mind. So here I've got a whole bunch of apps that are set up, and I can go to the developers link down at the bottom, and where is...
They keep changing the page.
Yeah, so I want to go to the Facebook login, and there we go, my apps. Okay, so here's the apps that I've created, and I did this the other day. I created a game service, so here's the app ID. So I'm going to copy that, and I'm going to stick that over here into, oh, maybe not. Control V is not working. Let's right click and copy and paste. Oh, this is interesting. it's not letting me paste.
Well, we had to have another demo issue.
Yeah, you know. So, Steve, can you memorize that number?
No.
All right, let me try this. Let me copy it, and
Notepad.
I will, stick in my little notepad notes here, and then let's see if I can copy it out of here and paste it in. There we go. Wow, that was strange. Okay.
Facebook security.
Yeah. So now what I have to do is open this guy up, because I've got my app secret. So I'm going to show that and copy that.
But I can memorize that one.
Yeah, and it's going to go on the video too, so I'm going to have to delete this when we're done, or just reset it. That's the cool part, is that's easy to reset. And just to make sure I got this right, I'm just going to paste this out over here, and then select and copy it, and come back. Okay, I guess I'm in the right. There we go. So now I've got my API and my app secret, and I save that. Yes, please take effect immediately. And it does. It happens fairly quickly. So let me dismiss those. So I've got identity set up on my server side. So now I'm ready to publish this app into my my mobile service. So I come back to Visual Studio, and I go to Solution Explorer, my game service. I right-click and I publish. All right, and I'm going to go up to the profile. I published this on a different account earlier, so what I'm going to do is remove that one. And I'm going to ask for Steve's assistance here, because he is the keeper of the secret. And I'm going to sign in as x dash, what was that again? Minutes at Outlook. Whoops, that didn't work. Outlook.com. And it's going to take me to my account sign-in page. So I got to sign into, yeah. I have to do this again, because there we go. And now secretly pass me the password for. So we're doing this. I'm typing over here, and actually my keyboard is over by Steve. So now I got my keyboard back. All right, so now we're just waiting for it to come in. Great, I got selected. And if I drop the Dropbox down, there it went out to Azure Mobile Services. It authenticated me, and it grabbed all of the mobile services that are set up and provided it in a list, so that I didn't have to do any typing or remembering what this thing is, what it was named, right? Because I would have gotten it wrong anyways, because it's a dash and not an underscore. So I click OK. Now it downloads all the publishing settings and gives us all of this gook that we really don't care about too much, other than it should be set up correctly. So this is all the information it needs in order for Visual Studio to establish a connection back up to Azure and publish my service.
And if something like the password is blanked out for some reason, you can always reconnect like you just did.
Absolutely, yeah. So it always gets me too that over on the side where it's got the 4 steps, they're actually clickable. So you can go back to profile and manage those profiles, delete them, and come back in, because they're slightly gray. And that always gets me, it looks like it's grayed out, and it's really not. It's just the way that the coloring scheme works. And so you can always go backwards. If that doesn't get you, then there's always previous and next buttons down at the bottom of the dialog box to go back in the process and then work your way forward again. So publishing is really cool. And I love being able to do this from Visual Studio, because now I just click publish, and it starts setting it up, and it builds my project first. And as long as I didn't make any changes that were going to destroy anything, it compiles, and I can see it starts to publish. It's adding directories and sending files up to Azure, and then it's going to launch Internet Explorer and point me at the service, which is going to land us on a landing page. It's not going to be anything that's really great, but it's going to give us an indication that, hey, it worked. So, and here it is, and it worked. And if you're really kind of interested, you can just come down here to the little icon. It's a little happy face, and you can just click it, and it changes the light on and off. Okay, so
I've never seen that before. I've never tried that.
Yeah, I noticed that the other day when I created this first one. It's like I saw it bounce, and I was like, ooh, that's weird. So I clicked it, and it turned the light off, and then turned it back on again. So my light is on. My service is ready to go. So my next step is to, I need a little bit of information. I need to go back to my dashboard, and because I changed what subscription was actually being used. Actually, I need this one, the Lightning one, the getting started. I changed the subscription and the whole service that this was being published to. So there's a little bit of information that you have to put into your application in order for it to connect properly. And that's underneath this connect an existing one. All right. I can either download an existing starter project or I can just follow these steps. And so what I really need is this information right here. This tells the mobile service how to get connected. So I'm going to copy that. And so this is my mobile service client. And I can then paste that back over in Visual Studio. And where did I stick that data?
Probably in your app.
Yeah, I think that, well, you know what? It tells me. It says right-click your client project, go to Manage NuGet Package, add in this, all right, the Windows Azure Mobile Services. So this is the component that we need, and it's a NuGet package. So this gets added in, and that enables all this other really good stuff to happen. So this is all the guts. And then you just add a using statement to that NuGet package. And then in the app XAML CS, see if I could read and follow instructions, this would be not a problem.
But it wouldn't be as much fun.
Oh, no. So one thing to remember here, oh, what did I just do? Hopefully Control-Z fixes that. All right, so this could be interesting. So one thing that happens when you download the Windows App Store version is that it's now a universal project. So your app.xaml.cs is actually in the game.shared, right? It's in the shared project as opposed to being in each individual one. So I go into app.xaml, and here's my code. So use this constructor. So I just need to paste my code in here, and I don't need the localhost one. I'm not going to bother with that. And I just need these 2 lines. I'm just copy those out. I'm going to paste them in here and uncomment them. So there we go, game service -MVA, AzureMobile.net, and there's the key to get to it, which will only be valid for the next few hours. And I can get rid of that. So now it's all set back up. So now my client is configured to connect to the server. So if I launch this, deploys, it launches my game, and I've got a big sign-in button. So if I click the sign-in button, all right, what'd I do wrong? Ow, I know what I did wrong. Okay, so this is Facebook security telling me that, you didn't set up your application's mobile service correctly with Facebook to tell it that it was right. So let me close this.
Switch where the mobile service.
Because I switched where the mobile service was, right? So I need to grab this URL, right? Because this is where the authentication request is going to come from to my Facebook app. So here's my Facebook app, and settings, and then here, my site URL. All right, so I just paste that in here. So this is specific to the Facebook side of things, but essentially it's going to be pretty much the same for all of these identity providers that are based on something like OAuth. They're going to want to make sure that they know who's contacting them in addition to, that you're contacting the identity provider. So there's a two-way type of authentication stuff going on here. So I'm just going to save those changes. And hopefully if I go back to Visual Studio and run this again, click my sign in button, connecting to the service, and now I get the Facebook login, and I can punch in my @ and my secret Facebook password. And I'm going to log in. I'm not going to check the box to keep me logged in because I want to make sure that I go through this several times. And also, because I'm in a Windows Store app, remember, it's now asking me for that single sign-on experience. So we can either agree to this by saying yes or skip it. I'm going to skip it so that we see how this works. And it tells me now I am signed in, and there's my Facebook ID. So this is the user ID that Facebook is returning to us and that I can keep track of. So now if I want to create a user profile, that's the ID I can use to keep it associated to that particular identity. All right? So this is my identity.
And you had code to do that pop-up. That's not automatic.
No, this is not automatic. This was in the Visual Studio code I had. So after authentication, it threw up a message box.
Okay.
Yep. So
want to make sure people aren't worried about pop-ups coming up that they weren't exposed or wanting.
Yeah. And so the error I was getting earlier came back again. So it can't request the data from the mobile service. But that's something we got authenticated, right? So that's really what we were looking for. So let me stop this. Where'd my stop button go? Debug. Stop debugging. Okay. So yeah, so you said there was a message box, and that's right here, really a dialog box that we threw up with that message in it that is, you are now signed in and the user ID. Yep. So, to show you a couple other ways, this is the simple way, right? Authenticate basic. And if I just change my thing up here, let's go right for authenticate expired. And we can see how you can handle not only caching your credentials when they come in, but also like what happens if, nope, that's not the one I wanted. There we go. How to handle what happens when your credentials expire, during your session, right? So if you're logged in and you're not doing a whole lot and this session expires, how can you get this to come back in? Now, the average or the default timeout for Azure authentication tokens to expire is 30 minutes. So that's a long time to have to wait when you're debugging. So there's a quick, easy way to test this out if you're debugging, is simply to go into your Azure portal, and underneath your mobile services, there's a way to manage keys. And that sits right here. All right, so there's this button down here for managing keys. You click that, and then you can regenerate either the app key or the master key. And that essentially will invalidate any token that's currently generated with that application key. So that way you can test this. Now, the only problem is now you got to put that key back into your code. But it's one way to test out to make sure that this code is working. So the way that this one works, as I described it earlier, is that we have this thing called an authentication handler. This is a special class that I actually have in my code. So here is the authentication handler. And what it's doing is it's acting as a delegate in between your code and all of the function calls that are going out to request data from mobile services. It's inserting itself in between there and saying, okay, let me test this authentication token, make sure that it's valid. So there is a send async method on here that it's overriding because it is a delegating handler. So that is the method that is going to get called. You can see that's an override here. So it's being provided to you from delegating handler. And it just goes through and tests out, making sure our mobile service client, all right, is valid. We then clone this request, all right, to make sure that we have a valid request. And the clone request is actually a helper function that's at the bottom of this. Pretty much boilerplate code on taking an HTTP request and making sure that we can reuse it. We then await a send async for that cloned request and a cancellation token. So this is the cancellation token that we got sent in from the async request. So we're doing another async call, so we send in through the same cancellation token. And as I described during the slides, if we got an unauthorized, so oh no's, what we need to do is try this again, all right? Try and see if we can't do a login async, okay? Force the user to log in again, and then clone the request, save out those user credentials. So this is a delegate function that gets passed in. So that is actually up here. So in the authentication handler, we pass in a delegate action that returns a mobile service user. So that's calling back into our client code. So now save it off. We then take the cloned request headers. We remove the XZoomo authentication header and add it back in again for our authentication token, and then send it again. Right? So we're just grabbing the new authentication token off of the user object that just got passed in from the client right here, and sending that request out again. So it's taking care of the case when we failed authentication. And so that's on the sign in click, right? So you click sign in, we get this authentication handler, we create a new mobile service client using our application URI and key. And then we set that on the authentication handler, right? So we need to have this client before we can do anything. Then we go off and we say, hey, go ahead and try and load the user, right? And grab this user. And that function is right down here. And this is just a standard function. It's not asynchronous or anything. But what we're going to do is we're going to check the password vault. So I've got my vault, and I've got a password credential here that is being stored in the vault, hopefully, that we're going to retrieve. So I'm going to use a try catch block to try and retrieve that from the vault anything that's labeled with Facebook. So because we're using Facebook as our identity provider, we can get the first one out of there. If nothing exists, then we're going to get an exception, and we can just throw it away because we know that we'll get this exception here, and when that occurs, we can ignore it, because what we'll do is you'll just check if the credential is null, which it should happen, and we can credential.retrieve password. If it isn't null, right, we can retrieve the password, so it was in the vault at this point. We can create our mobile service user and set the mobile service authentication token equal to the password from that set of credentials. So we get the username and password and set up our user and return that. If the credential is null, right, which means it wasn't in the vault, in this case, what we're going to do is we're just going to return null and false, right? And in that case, what happens is that, in the try-load user, we're not going to have a user in the vault, and so it's going to force an authentication on the client again, right? And this is, you can just ignore this. This would actually go out and grab the leaderboards if it was there. In this case, if we call this client.getTable and we don't have a current user on the client, it's going to force a sign-in, right? Because this request is going to go through our client, which is this mobile service client, which is attached to this authentication handler, or right? So this works exactly the same way. The code's just a little bit different. And as we said before, we're going to push all this code up, and we'll eliminate any of the little hazards that we've gotten so far with failures on these, make sure they work for you. So, in this module, what we've covered is authentication, authorization, and even a little bit of identity in there. Hopefully you've been able to glean a lot of information on how to handle authentication properly inside of your games, and you can take an Azure mobile service and add authentication to it and connect it into your game or create a new game off of it fairly easily. So we'll take a short break, and when we come back, we'll do some more.
All right.
And we're back, and we know who we are, and we're going to talk about something different now. So we're going to talk about some different clients that we can use with our Azure services. And so, Steve's going to walk us through on how to connect Unity and use WebSockets and connect to our Azure services. So, Steve, what does that involve?
Well, the nice thing is Unity is used by a lot of people. It is a system that is basically free for people to use until they start making a certain amount, $100,000. But what we're going to do is we'll talk a little bit about the overview of Unity itself, and then connecting to our WebSocket server that we had made earlier. And then, show the demo of all of that working.
Sounds good.
So overall, Unity is a nice little gaming system to where it's a 2D or 3D game engine. A lot of game studios and colleges both use it. You can do your scripting in C# or JavaScript.
Or Boo.
Not anymore.
No? Oh, in 5 they removed that?
Unity 5, I think they removed Boo. And Boo was actually a custom Python language that they had.
Sure.
It just was always fun to say, or you could code in Boo. We always enjoyed saying that at the events we would talk about. But I believe that then Unity 5, I think they removed that as a possible. So it's C# or JavaScript for your scripting. Now, one of the things I love about Unity itself is that you can make one game, one app, and target multiple devices, whether they're mobile, desktops, Macs, Windows, doesn't matter. You can do one code to rule them all and make it so that one game can go across anything. Of course, that also can be a problem because you might have a plugin for Unity that actually is set up only for iOS.
Sure.
Or only for Windows Phone or Windows 8. So you need to make sure that what plugins and what you're utilizing are compatible across all the platforms that you're going to be publishing. Now, a great thing about Unity also is its asset store. There are many assets and scripts that you can just download for free, or some of them are paid. A lot of them are paid. But you can download them and include them in your apps as well, including some of these libraries and some of the support for various things. Now, there also have been multiple MVAs to talk about Unity that have already been done.
Sure.
And the Unity website will also have a ton of video training online as well.
So are you insinuating that we're not going to go into detail into how to use Unity and creating games using Unity, but we're going to focus more on just how to use Unity and connecting to Azure?
Yes, that's what we're going to focus on. We're going to make the bare bones, minimal game, kind of like what we've been doing so far today, and just to make it as simple as possible.
Okay, but you have resources, lots of them out there for learning the intricacies of using Unity and getting a really good game built using Unity, which is a fantastic game development platform. So feel free to use those, and learn up on Unity, and we're going to show you how to connect that up to Azure or any other WebSocket server in this session.
Okay. So connecting to the WebSocket server. Now, the thing is that you have to remember, if we're going to be doing .NET, we're doing C#, one of the things is that it is .NET 2. So that's one of the reasons why I was using earlier the WebSockets for .NET, because that had a version that was for .NET 2. The one that's built into the .NET runtime is only for 4 and above. And if I actually built a Windows Store app, then I might be able to talk to it. But making a desktop app or a Mac app or something, I wouldn't necessarily have those available to me.
So because it's based on .NET 2, and we're still using the WebSockets for .NET, this essentially should be very similar to the code that we saw earlier on creating a WebSocket from a standard .NET app, as long as we're using WebSockets for .NET, right?
Correct. It's actually the exact, pretty much a cut and paste from one to the other, which works pretty well. Now, the main thing is we're going to add the reference to WebSockets for .NET, create a new WebSocket variable pointing to the server, and then tie into our open, closed, message received, and errors, and then open the WebSocket. That
sounds familiar.
It's very familiar, yes. So now a couple warnings. The WebSocket for .NET could mean that you need separate plugins for any platform. And those are in a plugin folder in Unity, and you'd have to have certain versions for each plugin folder that you're going to target, like a Metro folder. Yes, I know the apps are not called Metro apps for Windows Store apps, but under Unity, it is a Metro folder that everything is under. So you need, and if you're doing an iOS one or an Android, you need to have that DLL with that signature in that folder for the plugins. So there are resources in the asset store that might be a little bit better if you're making a cross-platform. Right now, I'm just making a standard desktop version of an app, so I end up using just the standard .NET 2.0 WebSocket for .NET implementation. So I'm going to switch over to my Unity. And what I did here is I started off with a simple 2D or a 3D game. And in here, there's a sphere in the middle of there. The sphere's not going to do anything. I just wanted to look at something other than nothing. But what I've also done is on the left-hand side here, it shows the canvas. I right-clicked and I was able to add UI, and I was able to add a button. So I added a couple buttons here. One is for closing, and you can see on the right-hand side the word close. This is the inspector, which shows us everything about the selected control that I'm on. The second button is actually one that's going to send a test message. So those are just two buttons that are kind of out in the middle of space. But one of the big things is that I added a C# script. You can right-click and create a new script. Notice that C# and JavaScript are the only two. Boo is not listed anymore. No boo-hoos for lack of boo. And I created this C# script. Now, by default, MonoDevelop gets launched. That's the editor that Visual Studio, or that comes with Unity. Now, what it's going to do is you can tie in, there is a plugin, so you can use Visual Studio as well, called VS Unity. It's a free plugin from Microsoft to be able to add in, but I wanted to show you what, by default, if you're downloading Unity itself, what you're going to be seeing. So here I have in the source code, I have my using for the WebSocket for net. It also added a SuperSocket client, and we need to make this one a little bigger.
Yeah.
Much easier to see now. And in the start, the scripts in Unity actually come with two functions by default. The first one is start, and the second one is update. Start obviously gets called when the script starts, and update gets called every frame, every redraw. So I have nothing in the update, and I just end up creating the WebSocket, and I talk to my local machine here on my 2012 port. I tie it in for the open, the close, the error, and the message received. Now, what I did is, in this case, I actually did something a little different and hard-coded in the JSON that I'm sending over. So instead of creating an object and doing like a Newtonsoft JSON converter, I end up doing it manually. Reason being is there are, again, the JSON converters. You have to make sure to have a .NET 2 version of the JSON converter and things that are only on .NET 2. So you do need to be careful. There in the asset library, there are quite a few. There's a JSON parsing plugin, as well as some WebSocket and other plugins available too. So back to the code, looking at the WebSocket send, I actually created the login for Steve from Unity, so it's going to log in and give me that name. And then when I press the button for sending a new message, it's just going to send something that says new message sent. And then the close button will actually just do a WebSocket close. Now, when I run, I'm going to do a build and run. One of the other things is that they do have in Unity a way of running everything from inside the editor as well. But I'm using a desktop version of these libraries, so I'm running it separately to bring up. So here is the nice little made with Unity symbol. Here is our sphere. We have our close and our send buttons. And I'm going to Alt Tab. I don't have my server running. Well, I guess it's not going to do anything if the server's not running. So let me run the server code.
Demo fail.
Demo totally failed. So I'll start the server back up, and this one that we had earlier, so it's fairly familiar to us now. And let me do the build and run. And I'm going to actually run it in a window so we can see the output as well at the same time. And just move that over a little bit. So when it logged in, there's my connection, and I have the Steve from Unity logged in. Now, if I could send a message, the server code is actually taking that as the player moved. I could tie that into my mouse movement. I could tie it into the moving in 3D. And apparently Michael has now logged in as well.
I launched it on my desktop as well, so it can't be left out.
No, it wouldn't be fun to be left out. So if you now, obviously right now we're not saying who the player is that moved if you hit the send message button. Now on the close button, it will actually remove the connection from the connection window. And so now nobody's connected to our game. So if we look at the code again for a second, all it was just a WebSocket send. So whether I'm sending my login or any message at all, it was that simple to be able to send a message up to the server. Now it's the server logic which would then broadcast that out to other people or allow us to do something else to be able to tie in and say, oh, Steve left the game, or to say that my character got blown up or something.
Okay, so we have a little bit of extra time right now, and I was wondering whether or not we could, right now set it up so that your server can send a message to my client, and we can be able to do something very simple like instantiate a new sphere in our scene inside of Unity.
We probably could do that.
You want to try it? Are you up for it?
We can try doing it live.
Okay.
All right, we can. Let's do that. Now, what we can do is on the Unity side, and I'll let you do some of the Unity changes on your side.
Okay. I can do the Unity side. You do the server side.
I'll do the server side. So where on the WebSocket message received, you have to then actually do a creating of a new sphere and things of that nature.
Right. So in Unity, that's instantiate.
Right.
Okay. So I instantiate a new game object. In this case, I've called it WebSocket. Not WebSocket. That's what you called it. I created a public method or public property on my mono behavior game object and called it sphere. So then we'll set this behavior up and pass in the sphere that we want to create. And then I call instantiate sphere, and I believe I have to, nope, I can just pass that in as it is. So I can just instantiate the sphere on that spot. We'll do some stuff on it to make the sphere move automatically for us so that we can see them being created, right? So if I save that, now if I go back into Unity and we take a look at the scene, I've got my sphere here, and I've got a prefab. What's the prefab that you created there?
Well, actually, I did not make it a prefab right now. So what you can do...
So I need to take my sphere and make it a prefab.
So drag it down to your asset folder somewhere there. It'll make it into a prefab.
All right, so now I've got my prefab. Where did we attach the new behavior script? Is that on the main camera?
I actually attach it to the main camera.
Okay, so there we go. And you can see here, there's the new sphere property I created. So it's already assigned and set up out here. So I'm just going to drag my prefab onto that sphere. So that's set up. So now when I get a message from the server, it should instantiate that sphere. And because we're going to deal with prefabs, what I'm going to do is I want to add a new behavior to this. So I'm going to add a component, and I'm going to add some physics, and I'm going to make it a rigid body. And just simply doing that should give it mass and gravity. So now it should start falling. So when we're in our scene, we should see that get created and then fall. And I'll add one more component just to give it some effect. And I will give it a trail renderer. So that way we can see streamers coming down off of it as it's falling down. So it should cast shadows. We'll use light probes. The start width, let's make it kind of large so we can see it. I'll up that to, let's do 3, and then it ends at 1. So it'll be a trailing ribbon as it flows off of this scene, flows out of the scene. So that should be all I need to do on the Unity side. Let me make sure I didn't break anything. So I'm going to build and run. And
now, let me start my server so you can connect to it.
Yeah, well, it's okay. I just want to make sure I didn't break anything so it builds. And then if I click play, I really shouldn't notice anything different in this game now because, I still have that initial sphere. Oh, there we go. So it did, because it associated my existing sphere to that one. So there we go. That's what it'll look like if we get a message and it's going to create a new sphere. It should sit there and then trail off and create that nice pink ribbon. So.
Okay. So what I've done now on the server side is I've actually added a more spheres button so that I can then say, hey, we need to give more spheres, and added a function on there to this. On the code behind, what I'm doing is I am going to, when someone new connects, I'm going to save that off into a sessions variable. And I'm just going to add that one to my session so that I can keep track of all the sessions that have connected to me.
Okay, so you got a list of sessions.
I wasn't keeping track of that yet on the server side, so
it was just in the list box.
It was just in the list box.
Okay.
So now what I can do is I can then say for each session, for each object in sessions, I can now come here and do a send. Now, what was it? You just had it say any message? It didn't matter?
Yeah, on any message. It didn't matter. So all we need to do is send the message, and if we get it, then we should create a sphere.
I would say more cowbell, but we're doing more spheres.
We're doing more spheres.
All right.
Not everybody's going to understand that reference, so.
No. All right, so now we have our server.
Okay, looks
Up
like
and
it's
running.
Okay, let me start my client, get us connected. And awkward silence as we sit here and wait for things to work. Okay, so we're windowed mode, play, and made with Unity.
I do like the new
Yeah, I do too,
logo,
you know. I
this
haven't
animated
looked at it too
logo.
much, but it was cool. Okay, so there's my initial one falling off the board, and there it goes. Okay,
All right.
so now,
So I'm going to click on my more spheres.
yep, and you can see one drop, and another. Look at that. All right, so now we've got two-way communication going on between a Unity client and just a standard .NET application server, right? Using WebSockets. So, you know, we've got the beginnings of the infrastructure for, you know, our next MMO, right? Take the code and run with it.
Absolutely. Now, and the thing is that we are able to take this and utilize this and add anything we want to it. Now, we added it to where it was on the button, but I could have actually set it up to where we were moving around with a joystick. Maybe Unity does have some great support for things like adding in a joystick or adding in like Xbox controller, things of that nature, and being able to utilize it.
Right. The idea is that, you know, the event is a button click, but really on your server side, it's whatever event happens to occur inside of your server code to cause this action to take place and send the message. So, you know, we've kind of modeled it using a button click, but that could be anything that's happening inside of your game world. So as, you know, the clients are sending updates as to their position, you know, when a client gets close enough to a certain object in the world, you could fire off an event that causes something to happen on the client side. Create, let's say, you know, if a player gets close to a section of the world where there's a fire pit, when they get within a certain distance, you can have it fire up that fire and create a particle effect inside of their Unity client that they can see as they approach. You know, not something that's going to be, you know, in effect as they are from a distance, so you can save on some cycles on their client side. You know, have other things like that occur.
Well, and the nice thing is that it was fairly easy to add. I mean, it really wasn't that much different than.
I know I threw you for a loop there when I asked, but I knew it wasn't going to be that hard to make that next step.
Yeah, that whole thing was not scripted at all. We just did that live here for this, but it's nice to be able to add these things quickly and easily, and utilizing something like a WebSocket. Now, Unity itself has its own networking system. We're not putting that down. We're not saying it's horrible. We're not saying anything. It has its own system. There's lots of other networking systems as well. This is just to show and demonstrate how you can make your own server side. You can do your own controls and do those things. Now, I want to go back to the Unity for a second and take a look at one of the things that I said earlier about the asset store. One thing about the asset store itself, I mean, they do deals and sales and everything else, but there is someone that has a JSON library that, once it pulls up, will show that it's actually easy JSON. There's JSON objects. There are JSON to C#, JSON.net for Unity. This is the one I was thinking of. And it's not a free plugin. It is a paid one. But it is, I believe, actually the exact same interface. It supports JSON and binary JSON. And it supports the free version and the pro version, and works on iOS even. And it's the exact same interface as the normal Newtonsoft JSON.net interfaces.
Free one.
And this way, this comes down as source code into your plug and all the plugins. And you don't have to worry about, well, what version do I need? No, this plugin you actually add and install. Take a look at the various plugins that are in there in the store. There are WebSocket ones. When we start talking about the Photon and server at the end today, there is a Photon plugin for their networking as well. So there is a lot of different plugins in there to be able to support you and do what you'd like, as well as full assets and meshes and things of that nature.
So cool. We had Unity connecting to a game server that we could host on a VM in Azure and do
Yes.
two-way communication. I mean, for 25 minutes, that's pretty impressive.
Well, the nice thing is we did a lot of the work earlier, and by using that same kind of logic and using that same thing, that really helped us out a lot. And sometimes the making of these small little test apps and test programs really works well, especially when you're trying to do something new, like putting it up in Azure. Whether we're running it locally, we're running it up in Azure, it doesn't matter. It still was running it in a virtual machine, and that's what we really cared about. And it actually worked out real well.
Yeah, it did.
So now the next session that we're going to be coming back to is we're going to be talking about how to do this same type of thing in Construct 2. And that's going to have a few more gotchas because it's a very specific system written for HTML5 and JavaScript and its editor and its controls. But that's going to be the next one so that we can do even the exact same server, exact same everything else, and do that game as well.
Excellent. So we'll see you in a few minutes.
Welcome back, and hopefully you enjoyed the little bit of Unity that we talked about. And now we're going to switch topics a little bit to Construct 2.
I know I enjoyed that Unity stuff. That was a lot of fun.
Well, again, especially since you on the fly had me change the demos and everything else. I mean, of course, when don't we do that with each other?
Yeah, really. Get ready for it again.
Oh, man, really? Okay. So we're going to start talking about Construct 2 as the client now. And Construct 2, we're very similar. This looks like the last slide deck. Overview, connecting to the WebSocket server, and then data conversion. That's a slightly new one here because Construct 2 does things a little differently. So I had to do some interesting ways of connecting the data back and forth. Mm-hmm. So Construct 2 overall, I know I started using it a few years back now, but it really is an HTML5 game creator designed to make 2D games.
Who makes Construct 2?
The company is Scira, S-C-I-R-R-A.
Okay.
And it really is a very simple system that I know that we have had in some of our events in Boston, 8 and 9-year-olds making games using it. I was helping out with a first robotics class, and they were had to do a project as well as the robot, and they made 2 games using Construct 2. We combined them together into one game, and they took first place in the project category.
Awesome.
Because everyone wanted to play the game at the event. So, I mean, they were a basic game from some of the templates that are built in, but it's kind of nice that 9-year-olds were able to do that.
Right.
One of them was a tower defense to where it's all about health for them. So it was the cupcakes were coming against them and they had to shoot carrots at the cupcakes and destroy the cupcakes. And the second game was actually a doodle jump type game, and you could jump on pictures that were healthy and it made the platforms bigger. And you jumped on things that were not healthy that made them smaller. And that was made by 2 different kids. We combined them and it worked really well.
Nice.
So, I mean, it's good for all ages and it works as a great system. Now, there is really it's an event-based system. Now, if you don't understand what I mean by event-based system, it's kind of like an if and then. If something happens, then do this. And most kids understand if I get caught doing something bad, then I get punished. That's how I explained it to the younger kids.
Or if I do my homework, then I get the reward.
Or if we change the demo, then no, just kidding.
Yeah, how many if-thens are we going to come up with here?
Now, so it's a system, so there's no coding, it's just a setting up of the if and thens. They do also have an asset store to purchase different things, and there is at least one other MVA that is going into detail on Construct 2. So if you want more details on it, watch it. It's a great little system. Now, connecting it to the WebSocket server. Now, this is JavaScript based. That's what it makes. And WebSockets are JavaScript based. So it actually works really well. You can add a WebSocket object to the layout and then add events for connecting on message. And then when you start the layout, you call the connect and give it the address of the server. This seems a lot like the Unity one.
Yes, it does. Different tool.
Different tool, though, yes. Now, the last thing that I want before we go into the demos and take a look at it is data conversion. Now, in Construct 2, see, I keep saying Unity. In Construct 2, they actually utilize a dictionary for various things. So instead of creating an array of something, you would have a dictionary. And that we can keep a dictionary for data to be sent and data to be received. But when it actually sends out the data, it is sending it out in the format here of a C2 dictionary true, and then all the data is coming in as a JSON object underneath the hood. So what I had to do is I had to actually add to the server code to parse that out.
Looks a little cryptic.
Yeah, it's not the most straightforward. Now, what I did is, because I didn't want the server to have to send the same message to two different kinds of clients differently, so I actually added some this wrapper code here to inside of the Construct 2 app, so that it's going to receive the data normally from the WebSocket, and it's going to automatically transfer it back to a dictionary using this.
Nice. Okay.
So
you're going to show us that, right?
Yes.
Okay.
Now, warnings that the browser, it's going to be doing everything in WebSocket, so it's going to be running in a browser. You might need to use Chrome instead of IE. I have seen that as issues occasionally.
That depends on your version of IE that you got running on your desktop, though. So if you've got a later version of, I think it's IE 10 or later,
10
has
or 11,
WebSocket
yeah.
support. So as long as you're up at those levels, you'll be able to use IE. Otherwise, Chrome is your best bet.
And also, Construct 2 does not support the new Spartan browser that's for anyone that's running Windows 10 and running the new ones, if you're on the insiders or you're demoing it or trying it out. It doesn't list it, it doesn't support it. Will it? I'm sure it will at some point in time. But currently it doesn't support it. So let's get going into our Construct 2 code. So first, when I'm coming up into Construct 2, and I'm going to do what you can do is here say File New, and you get a list of tons of different games and sample projects, from a turret defense to a space shooter, top-down, auto runner. You get a choice. Flappy Bird, puzzles, physics catapulting, lots of different types of games that you can make very quickly and easily. And they're really just samples. They're templates to get you started.
And you used one of those to get started with this, right?
Yes, because I didn't want to make my own platformer game, so I just used the basic platformer to get started.
Okay. And what does that look like?
So the basic platformer ends up looking like this. Now, you have your player, can jump, run around. Of course, if you fall, you'll start back at the beginning again.
Nice. So it's a complete template. It's a full game right now that we're playing around.
Pretty nice little game. You can jump through things, jump up, even dropping down through them. So it's a pretty complete little game you could do a little hide and seek if you wanted. So if we got each other's position in the game, we could actually do a hide and seek or a chase me or something like that.
So we're going to break this thing, right?
We will absolutely try and break this thing. All right, so what I'm going to do now is first I'm going to start up the server that we had before with our brand new More Spheres button.
Okay.
And I'm going to I'm just going to take a look at a few of the different parts of the event sheet. If I look at the layout, it actually shows us the full game itself, but the event sheet is the important one right now.
That's the logic of the game.
Correct. That's the brains. That's how we're going to be running everything.
All right.
So on the right-hand side, I had to right-click and insert a new object, and I scrolled all the way down to the bottom, and they had a WebSocket control. Since I already have it installed on this, I'm not seeing it here. There is a multiplayer for doing their own using WebRTC data channels, but we already have our server. We already have our game. We're connecting to it with Unity. So why don't we connect to it with this one as well? So I just use the standard WebSocket one. And we can see that in my list here where it just says WebSocket for objects. So on the start of layout, what I'm doing here is saying connect to the WebSocket. And when I do this, it goes and gives me the nice WebSocket, my local host. That looks real familiar. We're using that all the time.
So if I want to connect to you, I have to put in your server IP address.
That's put in my IP address.
Or the server IP address of the server that's up in Azure.
Correct.
Okay.
Now, when I create a new event, here at the bottom, say add new event, I can come here and say I want to add an event for my WebSocket. I can say I want something on a message or when it's closed or when it's open or connecting. And I had already set these up here for on a connection opened. So I'm going to clear the text that's on the screen. I clear my dictionary. I'm adding the key name login name with the value Steve. And then I'm saying my socket, that's the WebSocket symbol, send that text from the dictionary as JSON. Because that login name was the only thing, if you remember from our data structure, the only thing we need to do the login with.
Yep.
So my server
Not
is...
very secure, by the way.
No, not very secure.
Okay. We're going to have to improve on that.
Well, not for this game.
No. Later,
So,
after this session.
all right. Notice that it actually did say now that I am connected. And if I go over to the server, there's my session. Steve is logged in from Construct 2. And since I heard Michael just click, I'm assuming he might be logging in too.
I've got the wrong server IP address. I got to fix that.
Okay, he's going to fix his. So we're connecting, we're talking to our existing server. And even if I click on the more spheres, which you would think might kill us because that wasn't coded in here, we do have that we did get our data sent to us from the more spheres. Now, we're seeing all this here coming up saying, we see that Michael actually did connect. And it's coming in and it's actually saying that he is moving around the screen.
And I am. I'm bouncing back and forth.
He's going everywhere on the screen. And the server on my screen is actually giving this exact position. So we could take a look at this and say, let me get his position sent back from the server to the other player, and then have it move my guy around wherever he is going. Or maybe I could even make another player and color it differently and say, here's my ghost player, my opponent, and I could try and follow him around maybe. There's a lot of things that we could do.
Yeah, that actually looked really simple to get this hooked up in Construct 2. I mean, we had our server already, so that was really cool. And then we added just a couple of events into the Construct 2 in order to get it to send the data and receive it back. Now, you mentioned earlier that we had to do some data conversion in order to get things working correctly on the C2 side, make it consistent with our other clients. So show us where that was, and let's show everybody else how to do that, so because they may want to do this as well.
Absolutely. Now, one of the things that the platformer does support, though, is the idea here of the platform character is moving. And what I've got set up on this case is this is where it's actually sending all the data. So when you were moving your character around, it was creating my data, and I just changed the message to say Steve, but the integer of the player's position. Now I had to use an integer around it because otherwise it was giving me floating point numbers, and they were just huge numbers that were just being displayed.
Okay. So that's a Construct 2 thing, just to make sure that we're getting better data.
Yes.
Okay.
Now, when I actually get a message, since I wanted to only send the raw data itself, you get the message back as the WebSocket.message text. That's the text that came back. Well, if the JSON, to actually load the JSON into a library, you have to put in all of this C2 dictionary true, data equals, and then our string.
Okay.
So I had to wrap all of that around. And so what I do is anytime a message comes in, I display it, but then I also load it to this dictionary. Now, if I run this in debug, one of the things that it does is it gives me a bunch of different things to look at. But I can even look at the keys and what's coming back here on what's being drawn. So it is connected. I do have my keys and everything for what's coming back from my server. And if I look at all the data that I'm moving and I'm sending, I can look at this live as I'm moving, and this is what is coming through.
Okay. So we can see that our position X and position Y are coming back through there. It's a little small, but I can see it, and I'm looking at it from 10 feet away.
Well, to make it a little bigger on my screen here, we can. Nice thing is, this is all web-based, so the browser gets to zoom in and out a little bit better. The editing does allow you to come here, take a look at the player, look at all of his data, all of his positioning. I can even then change it too if I want to here.
Yeah.
But I don't want to do all those things. I want to look at the data that's coming from the server, and right now it's actually not showing anything, so I need to fix that actually. So it's trying to load the data from there and load our WebSocket message.
Okay.
And, well, I was actually getting the message back saying more spheres, not a positional or anything else of that nature. So if we really want to do this and maybe have you move the player around or something like that,
Sure.
we need to have the server change things around a little bit. So whenever he gets a position, whenever he gets the data at the bottom that I'm showing that I create for moving the character, whenever that message gets sent, send that out to all the other players. Okay, that can work.
Sure.
So we can make the change to the server very easily. So when we're getting the data, player has moved to this position.
Yep.
We're getting that on the server. So now what we can do is we can stop the server so I can make this edit. And come here, and for each person connected in my sessions, that's pretty much what we did on the button before. Item.send. And what we want to do is, this is the data we got in for the value for the movement.
Mm-hmm.
So I'm just going to send that data right back out.
Yep. Is there a way for us to not send it to our current client?
I could actually check to see what session they all were and what they came from. But what I'm going to do is I'm going to edit my Construct 2 app where you can be moving yours around, and then we'll have mine actually do the jumping around following you.
Okay.
So I won't do any editing or moving of my character, just so that we can see that it's working. And this way, you'll get the message, and it'll show up on the top of the screen that you got it, but we won't do anything with it.
So essentially, you're going to spy on me.
Yes, I'm going to spy on you.
Okay. Just to be sure that you're just going to spy on what I'm doing so you can learn all the secrets to the game.
Absolutely.
Okay.
This way I can then target you directly, fire the rocket at... No, I'm just kidding.
All right.
So
That's the next session.
that's the next... No. Oh, actually, yes, that is the next session. We're going to be doing playing
rockets.
an online game. So we have the server. Looks like that should work fine for what we need to do.
Yep.
And then...
Excruciating 3 lines of code there, by the way.
Yes, it was just a horrible 3 lines of code. And now what I'm going to be doing is when I get this information back and I have this loaded in my... Just want to make sure the data from server field here, I can then add another action, and I can say my player, set his X to data from server, and I have to actually get a, let's see, what was it called down here?
You can't do that.
I can't do that.
Let me tell you. It's called position X, lowercase p. You got to spell position right there.
It does help if I spell position right, though.
And you're going to have to capitalize that X. There we go.
All right.
So just for the uninformed here for Construct 2, what we're doing is we're creating an expression that's going to set our player's X position equal to this expression. Data from server is a object that exists that's holding the dictionary that we got back from the server that Steve constructed from our little envelope inside of that message text. All right, so we put those two things together, we stuff it through the JSON thing, and that JSON deserializer is actually putting it into a dictionary object for us. And we're using that, calling get, to get a specific property from that deserialized JSON object. Did I get it right?
Yes.
Awesome.
All right, so I set up the player X and the player Y. Every time I get a message back, we're going to be moving. All right, so
Okay.
the server is up. Let me make mine not full screen anymore. I want to get over to show the server as well. You need to log in.
So now I need to log in. And I'm connected and moving. Well, I'm connected, but I haven't moved yet. Uh-oh.
And I'm not moving at all.
Nope.
Now, the best way of checking this is I'm going to stop this and do it in debug mode so that I can take a look at when I'm getting the data from the server.
Oh, did you jump? Oh, you jumped.
I jumped.
Okay. Because I jumped at the same time, so it looked kind of weird.
No, but it looks like the data from server is never getting filled in.
Okay, so that's where our problem is.
Absolutely. So it's always been able to look at these things. We have our loading from our JSON string. We have that string coming up, true, data equals, and that looks like it should be all correct. Okay. So that is where we're actually dying here, is for the dictionary getting loaded.
Yeah. So does the WebSocket message.txt have to be in quotes?
No, it's actually outside of the quotes, and I'm ending all those together.
Right, but I'm just wondering if we need quotes inside of the JSON, right? Because when we look at JSON, it's quote, field, colon,
that's true.
value.
So let me add 2 more quotes there. And when we start having 3 quotes in a row, it starts getting a little scary here, but we'll see here. I'm going to do it in the debug mode.
I'm jumping, and you're not getting anything still.
I'm still not getting anything sent over to me for it. And
you know what, though? I'm also noticing that your text box isn't changing at all.
No, it's not.
So it doesn't look like you're getting the message.
It's not getting any. Now let me actually say more spheres. There we go. We got the more spheres.
Okay.
Can you move around now?
I'm moving, but you're not getting anything. So it's got to be back in our server code.
Now it's interesting because as soon as I did the more spheres,
oh yeah, it moved you.
It did move me.
Yeah, to 0.
Yes, because
the upper left-hand corner of.
It interpreted it.
Yep.
So, I mean, whether it's that I'm moving it from your code or moving it from the server, and it's really showing the fact that the server is being able to send us the data. Not sure why I'm not interpreting, we're not getting that one back over correctly.
At all, actually.
Yeah, and it's probably because
I got the message, I can see it on my screen that I'm getting the more spheres message as well. You can see it put it up there.
This is a silly mistake.
Uh-oh.
This is, because of the dictionary coming in from Construct 2, and I had to change things around.
You didn't
I put that in the normal movement code, not in the
C2 side.
Not in the Construct 2 side.
Okay.
So now if I stop the server, rerun it here, putting it in and doing the sending, restart our server, and
all right, I'm gonna have to reconnect.
You connect. And we've got you listed there. Let me connect over to it.
And you're getting a whole bunch of sphere data. Wow, that is not what we're looking for.
Well, the nice thing is I can go into the debug, and I bet I'm getting lots of data from the server now. It's still saying it's nothing.
Yeah, but we know you're getting it because it's in there.
The one reason why it could be saying nothing right here, if I pause, it might come up with something. The reason why is that every message being sent, it's clearing it again, which means that it is resetting it constantly to 0.
Yeah, and I'm seeing on my screen that the data element is coming up empty. So you can see here how it's C2 dictionary true, and then data, and then nothing. We don't get that end curly, all right?
Yeah.
So, hey, we could work through this and figure it out, and we will work through this and figure this out so that when we publish the code, you guys will have access to it, and you'll be able to actually run the server and the client and see these things bounce around. So these are things that you're going to have to do on your own as well. And these are the tricky bugs that are just a pain in the butt to get through, pain in the neck. And so, it's just one of those things where you really want to be just careful about it. And you could spend hours just figuring these things out. But this to me, this is the fun stuff.
Well, and having two machines to where we can bounce them off of each other instead of just from my one machine does help a lot as well. Because is it because I'm running two copies of the local game, or is it because I'm just not connecting? And that having a couple machines connecting instead of just yourself does help with that debug process.
Yep.
And I have to say the debugging inside of Construct 2 and giving you all this information is really nice to be able to do all this stuff with.
Excellent.
And I'm wondering if on the server side, if I say more spheres, because see, it's moving. Well, what I'm gonna do real quick though,
Okay.
is on mine, I'm actually going to not move. I'm going to delete this one.
Okay.
I'm not going to send the message for moving
Sure.
because what was happening is it was moving me
Sure.
and sending a message to move me
Yep.
over and over again. So let me start the server up again. I'm sure we can get this connected here. Michael will connect. I'll connect.
I jumped and you went absolutely to zero. So
Well, yeah, you're the one who's moving me and I'm going off the edge, but at least we are getting it coming from your machine instead
Yeah.
of it automatically.
excellent.
So we are one step closer.
Yeah, not as good as our Unity demo, but still, we got somewhere. We got the two talking.
Well, especially since we did that on the fly again.
Yeah, I know.
So,
But I didn't. You led it with this time though. So
I
on
know.
you.
Well, I did say, hey, we could actually do this, and they're like,
Yeah.
why don't we do this? It's not a bad thing to do. So now our next session is actually going to be a very interesting one because this is going to be a topic that Michael and I have heard about and talked about for a little while, but we're also going to be playing a video game that uses Azure and looking at it and looking at what they do and talk about how they've got things configured and running for all of that. And this game is something that they're starting to do. Age of Ascent is starting to do demos every Saturday for half an hour at a time and trying to get as many people as possible. So that'll be a very exciting demo, and we do get to sit there and fire rockets at spacecrafts.
Absolutely.
So
Nothing better than shooting rockets at you,
absolutely.
or at least at your spacecraft.
All right. Well, let's take a 10-minute break, and then we will come back and fire at each other.
Absolutely. See you
Okay.
soon.
Welcome back. And now we're going to be doing, not only talking a little bit about some of doing the gaming on Azure and actually showing some of this stuff, but this is a game that's going to be going into production later this year. And I think it's pretty, Michael, stop playing the game.
Sorry. I can't. It's too good.
It is a really good and fun game, that's for sure. So, it's Age of Ascent. And Michael and I, we've heard about it and talked about it for a while now.
Yep.
Since last summer. And
Yeah.
as soon as we were hearing about it, we're like, we want to tell everyone about this game. And they're like, no, you can't.
Yeah.
That didn't
Now we can.
Now we can. So that's why we're like, we need to share this with everyone.
Yeah, I've been playing some of the public beta tests that they were doing earlier last fall, and it's just been phenomenal. It's just so much fun to play with this, and like we were talking, during the break, it's like this is what we're going to show you is just a small part of this whole game, and this keeps me busy just for 10 minutes so far.
Yeah, they had to tell us that. Oh, well, there's 2 minutes back, and we're like, what? We're still playing. We wanted to play more. So, okay, so this is a small case study on Age of Ascent. And what we're going to be doing this time is a small overview, going over the design, and then doing a demo. Now, on the demo slide, I do have the URL, so you can then join us and play if you'd like to play as well. It is just a web-based game. There is no install. So, go over the overview for a second. So, Age of Ascent, made by a small company, 4 years old, from England. They have England and US-based independent gaming. And what they're making is a epic MMO in HTML5. So it's built for a web browser.
Yeah.
Now, it's also WebGL based, so there's nothing to install locally. Unlike the days of, when we were much younger, when we had to have CD after CD for installing games on our local machines, this is no setup required. It's launch the web browser to get there. Now, they do recommend for right now, they're having an issue with Internet Explorer, which is being resolved. So we're going to be playing on Chrome. And we don't have, they do have support for anyone that does have the WebGL support in there with the WebSockets. They do use WebSockets for all their communication traffic, which is kind of nice. But the space battle that we're going to be looking at and showing and demoing for you, and hopefully some of you playing with us as well, that's actually going to be only a small part of the game itself. So they're going to have a full online MMO attached with it as well. And so, yes, you could sit there and, Michael, are you still playing the game?
Yep.
Okay.
I'm beating you, by the way. I'm up to 6 kills, so.
Oh, man.
You keep talking.
Okay, I will keep talking while he ranks up the kills. So the nice thing about it is that it is actually going to be one single global server. Everyone plays in the same universe. So it's not sharded. It's not every world is separate like some of the other games. There is one world online. And they actually approached Microsoft to ask for help in getting all this stuff going, and we helped them absolutely. John Shuchuk actually has a nice blog post on this. I have some resource links at the end of the slide deck and linking to his article on this as well. So,
Evan, sorry.
Okay, the design.
All right, I'll stop.
No, you won't. I know that. Now, the original designs and thoughts and plans that they told us about, it was supposed to support 1 million people playing simultaneously in the game. Now, that's a lot of people. But once they worked out packet sizes and how much data is being sent, they figured out they could support 100,000. And they've been doing tests for up to about 40,000 right now. And I know that they've been doing at least like 4,000 to 8,000 people in the different sessions. Now, I don't think we're going to get 4,000 to 8,000 today with all of our people playing, but at least we should be able to get some people playing in there. They added some robots, some drones in there for us to be able to shoot at as well. Now, the details of the design, I'm going to actually just go to the next slide first. This is actually the setup of the design to where, and I know it's a little fuzzy, but I had to blow it up a little bit here. The users will actually talk to a gatekeeper service that'll open up a socket for you. There are web clients that are routing servers that then put everything to their management servers to their backplane. And this whole setup is what they call a scale unit. So they need to be able to, I'm going to switch back here. So it's the 5 core services running in Azure. The gatekeeper service for checking for free slots in the game, where to put you so you don't put all the users in one location in the space battle. And also securing the WebSocket for entry. The routing service, all it does is handle data flow from the browser and to the backend services. That's all it does. So now all of the servers they have running are actually what they call in the cloud service a large web server. So I believe it's 4 cores with 14 gig of RAM, something like that. And what it's going to do is it's going to allow us to have quite a bit of traffic, but they have multiple of these. So to handle 40,000, they don't have everyone in one area, they have them spread out. And also, of course, the routing service is going to handle any of the secure SSL type of connections as well, too. From there, it's going to handle everything to the interest management servers on its back end. Now, on those, let's say that you're crossing from one boundary to the next boundary in space, and your data needs to start coming from the next set of servers. Well, that interest server management servers will actually do all that and tell the routing ones, hey, look, that new routing server needs to handle their traffic now. So they spent a lot of time working on all of this layout and for handling high latency, because around the web, around the world, I mean, it's not going to be instant connection for doing all this. There's going to be some latency, but they've done a great job with it. And also with the interest management is to actually know, should all of the shots from my ship is Michael going to see those where he is or not? And so it's going to be doing kind of like your fog of war scenario, to where it's keeping things away so you don't have to render them as closely. Now, and when you get closer to objects, it's going to be rendering a lot more detail, a lot more objects. But that's when we go on to there, you'll see that there's going to be a lot of things being rendered and run at the same time. And then, of course, a backplane to be able to connect all of the different servers, their scaling units together. And this way, if they need to have more scaling units, they scale more up. They need to have less, they take those down. And it's all the backplane, which is doing all the connecting and routing information. Now, overall, I mean, they've been doing some very large-scale public betas, and they're running on 748 cores. Now, Michael, remember what we said earlier about Titanfall, how many cores it was running with?
Sure.
How many was that?
I don't know, you said it.
Over 100,000.
100,000 cores. Wow. That's a lot of cores.
That's a lot of cores. This game is actually running with 748. And they've been doing up to 267 million messages a second.
That's a lot of messages.
So obviously, the things we talked about earlier, even though they may have been about things like data packet optimizing and getting those smaller, even though those are topics that are a little drier when they're not shooting at each other's spaceships or something like that.
Sure.
But they're very important because there would be no way that they could handle that many, and they can handle over 100,000 concurrent users in one contiguous battle.
Concurrent users. That's not, I mean, that's like simultaneous, right? That's 100,000 people playing the game at the same time.
In the same battle.
In the same battle.
So the thing is that's kind of unheard of. EVE Online does a good job of doing a large amount of people. This is a much higher scale than EVE Online for one server battle. So what I wanted, and I think they've done a very good job of what they've been doing, and I can't wait to see the full game when it comes out. So, time for demoing.
Yeah.
So here is actually the link. Now this link is not going to be valid. This is for our live users here. It is not going to be valid after probably this week. So it will not be something that anyone could just jump onto, because we're actually running a special test. So I'll give it another few seconds for people to look at it, because it's prealpha.ageofascent.com/systemtest_msva.htm.
Yep. And for the best experience right now, make sure you're using Chrome.
If you come up with IE, it will come up with an error message saying that they have a small issue with it right now.
And we're not the only people in here, you know that. We've got a fellow person out here. He's been shooting at me.
Well, I can't log in with my. This is what you see if it gets IE. It gets you the wrong one, so I got to go in with Chrome. And so I will do an awesome name of just Steve. So you have someone shooting at you as well already?
Yeah, there's James out here is shooting. And I'm up to 8 kills, by the way. Catch up.
Oh, good golly. So you have your space battle. You have all of the different things going around. The asteroids are moving. All of the different ships are moving. There are... Oh, someone just shot me. You have all of these different things going around. I'm having a harder time actually destroying any of these ships. I keep not slowing down. Oh well, you're my threats. You are my threat. Of course, you're going to be the threat here. Now, so this is a pure web game. Everything on here is just using WebGL, and that's why WebGL is a great technology for game making right now as well too. And Construct 2 will export to this. I do not believe this was written in Construct 2. But also, here, if you want to see people killing things, Michael's probably killing things much more than I am. But
I had somebody else, I guess one of our viewers has logged in and And he got me for 40 points, so.
Oh, James is actually the CEO of the game company here. So he is going to be pretty good. Help us. My ship was destroyed. James destroyed. Thank you, James, for destroying my ship.
So if you get shot, hit F5 to refresh.
Well, no. There's a button on the bottom to restart it as well too. If you do get killed.
Oh, I almost had this guy.
James is a very good player. When you are the CEO of the company, you kind of understand how to play the game pretty well.
And almost got him. Getting away from me.
Want to see the explosion? There's the explosion. Okay. Now,
8 kills.
So the nice thing is that the tools like Unity, the tools like Construct 2, they all will actually export games in WebGL format. And utilizing the WebSockets and all of these types of controls and all of this multiplayer, that allows us to be able to use Azure in the back end. The same things that we did. Now, they are using the cloud services more so than a virtual machine. But that's the thing, is that doing it with cloud services, doing it with virtual machine, I still can spin up one of those servers. I can spin up using Node, a WebSocket server in like 2 lines of code. So it's a lot of the things we have in Azure are supporting, and this game is 100% utilizing Azure on the back end. Same thing that Titanfall was doing, same thing that more and more games are starting to utilize. Whether it is something like the Forza 5, where they gave us a way of doing your own character that was running for you, your own avatar that runs for you automatically in Azure against other players, or whether it's the full world, the full space world, or any of the others like this, or Titanfall. So there is a lot of different things that we can do with this. Now, this overall, our session, we talked about we did a lot of overview and a lot of simple examples. I don't think that anyone was expecting us to be able to make this game during this session.
Or under years so far, right?
Yeah, it has taken them quite a few years to be able to do it. And the thing is that utilizing Azure, utilizing the same things you can run on your desktop and putting that up in the cloud in a virtual machine, utilizing the databases, utilizing all of these kinds of tools actually help you to because this way, I'm getting attacked again. I keep seeing flashes of bright red where I'm being attacked by Michael, and it was by you.
Was it?
Yes. So
I gotta find you again then.
Yeah, I'm hiding. I'm hiding from him right now. But utilizing these same things that you would maybe have internally, but being able to then scale them up for a larger scale, that's where Azure is going to be really well and work well for you. Now, obviously, it's taken these guys quite a few years to get their game going. We don't know their company, this is the game their company is making. Absolute Warrior. Okay, that must be someone new.
Oh, GM Thundercat.
Oh, wow, we're getting more and more people who are attacking us both.
Yeah.
Well, that's why I'm trying to hide in the asteroids, and it's not working.
So that's where you are. Okay.
No, I'm now in the middle. Oh, yes, I guess I am in the asteroids. So the thing is that utilizing these, it's not instant. It's still going to take time. If you're writing your own server, like they wrote all their back-end servers. They did all this themselves. And by doing all this, it does take time to create all this, test it, work it. But if you're running on a VM, you can run all that locally. You can take your VMs in Azure and move them local. You can take local VMs and put them up in Azure. And that's a huge benefit for doing that. Could be a Linux VM, could be anything. And like I said, they're running web services, cloud services, and they're just using a WebSocket to connect to it. The WebSocket support works really well, and even in a real-time game like this, to where we're having, I'm not sure how many people now have joined the game against us, but Michael is the only one who has a chance of actually doing anything right now since I'm doing the talking. But that's okay, because he was doing much better than I was anyways, and he was killing me.
Yeah.
Oh, there's another Steven in there, spelled differently.
Yeah, GM Thundercat just bought it, so.
Okay.
Whoever that was. Not quite sure, but I chased him down. I'm kind of lost in the asteroids. I gotta come back into the real fight here.
But I mean, the first time I played any of the samples on this game or anything else, it was just amazing as to everything. Yeah, and Michael, even if you touch screen and the left-hand side, you can move the bar over.
This guy?
Yeah.
Yeah, to hide out the controls. I like down in the lower right-hand corners telling me the bandwidth and the message round trip, so it's 73 seconds.
73 milliseconds.
Milliseconds, yeah. So.
Well, and the fact of, and showing the performance of how many frames per second on a web browser on this machine, and these aren't the most powerful machines in the world, 30 frames a second in my browser. Okay, I went through an asteroid. Okay, good. It's interesting you can do that occasionally.
GM Thundercat found me. He got me a couple of times. And I do like that your targets. Oops, I don't want to make people sick yet. So the list on the side of your targets and who's hitting you, so you can see lists of people who are attacking you and which ones you've attacked before, and then it also tells you whether or not you killed them or not. So it's pretty good.
And like I said, this is just the small part of the actual game itself. But obviously a space battle is a big part of going and running a live game server like this. So I understand why they focus on this as the starting point for all of their samples and their demos. And it really makes sense because a lot of the MMO type of things, they still need all the communication channels. They still need all of those kinds of things. And I am sure they're working on adding other features and other parts which they're not doing demos on. Now, this Saturday, they are doing, right from the Age of Ascent website, they list out that they're doing another demo on Saturday. So definitely, if you love this kind of a game, love the old-fashioned Elite or Wing Commander.
Yeah, Wing Commander. That was the one that brought me back to when I was playing around. I was like, oh, Wing Commander was just the game back in, when I was in school, and just playing that and just having so much fun doing those space flights and battles and things like that. So this is a lot of fun.
Well, and the thing is, there's a lot of other companies. Star Citizen is doing the same kinds of space battle online type of game. Mm-hmm. And I don't know if they're utilizing a cloud server or not for a back end, but it really makes sense to be able to do that in the long run and to be able to support much more and more. Yeah. And unfortunately, if you are doing it with your own servers and you have to pay for all that stuff. Now, Star Citizen did a very successful Kickstarter campaign, and you can buy different ships and everything else of that nature. So they've got a lot of things going for them. But from Kickstarters to your own startup company, if you notice on the break slides, you'll see things like joining BizSpark or being able to get into any of the other programs that Microsoft has. And a lot of those help game makers. They help be able to get the tools or get the services and be able to run things up in Azure for you and help you do those. I know a company actually that is moving all their business. They are a fantasy sports league. And what they're doing is they're moving everything to Azure now for all fantasy sports that they run. So, I mean, if they can handle fantasy sports on there really well, I mean, it's a lot of people, that's like a very critical thing in their lives. So it could work very well for that. Or if people are going to sit here and play this kind of game for hours at a time. Yeah.
I mean, just during this session, we've got 32 people playing. 33 was the top number I saw. So, it's not a bad thing. And the performance of this is really incredible. So it shows you how well you can scale up some games, even if it's just a web-based game. And, OpenGL and the technologies that we have today for browser-based games, I mean, this completely flattens anything that I've seen before as far as a web-based game goes. Full 3D, multiplayer, it's got it all. And they're using Azure on the back end to do all the services. So it's awesome.
Yeah, the any previous game like this that was doing this level of 3D and textures and support, it was a box game that you bought and installed and took you an hour or two to install it and play and then get the updates. I mean, it's a web-based game. Updates are all automatic. They're just there.
Yeah.
So it's really got a lot going for it. But I thought this was a great little demo here of an actual live, this game is running on Azure. And not only the back, I mean, it's running on Azure. The website, it's running on Azure.
So a big thank you to James and the team to put this together and let us play for a little bit.
Absolutely. And I think they've done a great job with it, and I can't wait to see some of the enhancements. Now, the last session that we're going to be talking about today, and then we'll do a little bit of wrapping up and talking about a few things as well, too. But one of the things in our group in evangelism, especially when you were there, we talked a lot about the fact of what is a popular multiplayer server that people could just automatically use. And so we're going to talk about the Photon server. It's a very popular one, and you can download it and try it out for free and be able to utilize things. And it does have an Azure support built in too. So it's kind of nice. And obviously we're going to be doing things like tying into our virtual machines and things of that nature. So we'll take a quick break or keep playing, either way.
Maybe both.
Maybe both, yes. And don't shoot me too many times. I'm getting killed like left and right already. But I'm sure Michael will shoot a few more people, and we'll come back and talk about Photon servers, installing someone else's server in your VM, and go from there.
All right. And we're here for the last session. I'm so sad. It's our last session for the day. We had so much fun playing that Age of Ascent from the last session. So now we're going to wrap it up. We're going to take a look at a full-blown server that we can run in the cloud that you can connect to using Unity in this case, which is one of our easier ones. Photon. And so, Steve, how do we set that up?
So Photon, well, first let's just go over a little bit about what Photon is and everything else.
That might be a good idea.
We don't want to just jump into saying, here's all the steps. We want to let people understand why they might want to use it. So what is a Photon server overall? So Photon's actually a set of servers, and it can be used on Azure or locally. And they also have their own servers as a software as a service type of thing. Some of the ones that are pretty easy are load balancing, a chat server, and a game server. Now, you can sign up for a free 100-user license, and without a license file, you can have 20 people connect at one time. So you can get a chance to, now we had like 183 people connect to that other game at most there. So you could connect with a smaller crowd to one of these.
Okay.
And they do have an SDK, so what you can do is utilize their server-side logic, their cheat prevention code, all of the things for doing all the communication and everything else, and to be able to handle various clients. And then you can just add on your own logic on top of it. So there's a really nice SDK that you can download. And this is actually a system made by Exit Games. And it's a pretty nice little system overall. But why use Photon? As we said, the Age of Ascent game, I mean, it took them a long time, and a lot of their code was actually on the server. So writing your own server does take a while to do and to figure it out. And just like with authentication, we didn't want to really reinvent the wheel. Have I made my own password system? Yes. Has Michael? Yes. Has half of you probably done this? Well, some of you might have already done that. Well, we don't need to do a new authentication system. We don't need to make our own server if we could utilize the Photon server.
Yeah, that is, unless you really want to. If you want that learning experience, or you think that you've got this great idea that's only going to result, it can only be done through a custom server, go ahead and build your own, but also realize that you don't have to go through that effort. You can use some stuff that's off the shelf, like the Photon server, and spend more time creating your game and focusing on gameplay rather than focusing on the mechanics of server-side processing, etc.
There was actually a team at my college of graduate students, and they were making their own game server. And what they were doing is they were actually coding it in the language D. I'm not sure why they used D, but they decided to use D. And they ended up putting it up onto an Azure virtual machine to run tests against. Yeah. So it was pretty nice, and they were very happy and pleased with being able to run their service and their project, even though it was in a very obscure language and developed in it, to be able to put it up on Azure. But also the thing is trying to come up with things like how to prevent cheating. That's huge. That's going to take you a long time to be able to figure out doing things yourself. And obviously, making a game yourself, anyways nowadays, is a hard concept. You're typically working in teams of people. But having it to where, Photon actually has plugins, as Michael said, into Unity. So this way you can add it to Unity game very quickly. So now one part of your team could be working on the server, whereas one part can be working on the Unity game itself. So it's kind of nice to have a system for doing all the communication automatically in there. And of course, you can run it on your own servers as well as running it up in the cloud. So, and they have it set up real nicely for a lot of this. Now, let's talk a little bit about installing it.
Okay.
So really, you download the SDK, unzip it. That's really the install process. And what they'll have is a deploy folder, and they'll have a 32-bit or a 64-bit version in there. The Photon server actually is .NET based.
Nice.
You look at it and look at some of the DLLs. It uses system.web, and it uses log4net for doing its logging. And now you can run the server as an application, or you can run it as a service. Now, if you're setting this up in Azure and in a virtual machine, what you probably want to do is to run it as a Windows service. Having that as a Windows service means that even if the server, you're not logged into the server, it's up and running. And unfortunately, if you just have it as a startup process and someone has to log in for that app to run, that's not going to help you if your server had to go down or you restarted your server. That means you're going to have to log back into it. If it's running as a service, if the machine has to be rebooted, let's say you're going from 1 core up to 2 or 4 cores, that involves a reboot of the server. So as a service, that would automatically reboot and run. Makes it a little bit more self-contained.
Yep.
So let's actually take a look at it. Well, let's connect with Unity first and look at that. There is a plugin on the server. I think you actually went into Unity and brought that down locally for you.
Yeah, I just did it a few minutes ago. Took about 5 minutes to download it and install it, and it comes with a set of demo scenes that you can load up and test against your server once you get it installed. So I've got the demo scenes here, and we'll get the Photon server set up and see if we can. Well, we won't see if we can. We will get it set up and be able to connect to the Photon server and have a demo scene running against the Photon server.
Okay, I just need to, all right, I'm going to stop my current one that I had running here. And so I'm going to show here my desktop with the unzipped Photon Azure. They actually have one that's specifically for Azure in their SDK.
Nice.
And they have full documentation on how to set up the server, counters, licensing, even to the point of going into the application for an MMO demo and how to get things going with that as well.
Okay.
A library, all their different libraries, and notice the log4net and Ionic Zip, all of the various .NET libraries for doing things, and even using Unity Editor too. And they even give you source code, so I can come here and make my own lobby, load balance it, do something in Manage C++, or even look at a client. Here's a Unity 3D client or a .NET client for the test MMO.
Nice.
And all of that is just in their SDK and download. I'm going to come to the deploy, though. And since I'm running on a 64-bit machine, I'm going to go to the bin Win64. Now, I can come here and do this deploy prompter, and it'll say whether I would like to build and copy server binaries to the deployment folder for which product. And I'd already done the MMO demo.
So I've got a note here that says we should do load balancing in order to get the demos in the Unity project to work.
Okay. So we'll definitely give that a try for the load balancing. And so I will hit 6 for doing some of the load balancing. And it's going to come through and do all the building and everything else as we're going. And it's done already. Press any key to continue. Always a nice thing. Love things being quick like this. Now, I'm going to come up here. We do have the MMO, but what I'm going to do first is I'm going to come up here. This is where we have the running Photon as a application, installing a service, starting the service, stopping a service. And here itself is actually the Photon control panel and the socket server itself. The control panel, if I run that, what it's going to do is it's going to run as in my system tray to where I can do load balancing. I can look at my license information, so I have it as a max of 100 connections here. Looking at the control, looking at start as an application or install the service. So right from that control app, I can do everything.
Right.
Or I could actually run these command files to install it as a service or anything if I would like as well.
Yeah, I like the handiness of the tray.
It is nice because this way I don't have to find this folder again.
Yep.
So I do like working with this kind of a thing. So I can come here to the load balancing one. I can say start it as an application. And what it's going to do is it's going to start running it. And if I go back and look at it again, it is going to be running. I can run a test client. And all this test client ends up doing is going through programmatically and testing out the environment. So it found 4 games visible, 3 clients, all connecting. It's nice to have an automated test like that.
Yeah.
Because it is so hard to know where your error went and what problem happened without knowing where your server is. So if I come here, I look at the game IP configuration, I get to see my IP address, the local one, the public IP address, which I believe that's the one you were trying to connect to before, was it not?
No, I was doing your internal, local, I believe.
So you can change yours to you can do auto detecting of this, looking at your performance counters. And anyone who's done a lot of debugging of server side things in Windows, they use the perf counters and be able to look at tracking of performance, looking at different things from drive speeds to network performance and everything. So having that available right inside of the control panel is very handy as well. So were you able to connect over to it, or?
Nah, I'm getting another error. I'm getting forcibly closed by the remote host when I try and connect. So still having a little issues here.
All right, so let me stop the load balancing service right now, and I'm going to come up to actually our MMO demo. And so here it has the full MMO demo, all the configurations, and this is what it built for me earlier. And it cached everything for this demo. And here was the load balancing one, here's the MMO one, and I'm going to see if I can get the MMO one to come up in the, yep, it all copied complete. See if I can get it to come up in the control panel here. We have our default one. Let's see if I can start that one as well. Now, the issue that you will see sometimes when you're running someone else's server is you need to go into deep detail into how to run it, how to set it up, how to use it, how to expand it. Whereas if you're writing all the code yourself, you know how to expand it. Michael and I actually went through and added that in the Unity demos for doing that adding of the spheres live during the session. And by doing that and knowing the code and being able to go into the code yourself, you do have a slight advantage. But if you're not familiar with this code and the way this server is set up, then it might take a little bit of time. Don't get frustrated with it. Utilize it to be able to create your own servers. I'm sure there is some phenomenal demos on setting up the Photon servers. Just like with Unity and Construct, we're not going to be going over how to do these things. It's the fact that Azure is supporting it, and Azure, all the different things in Azure are available to support this. So I believe I do have my machine up here and running, and I do have the Photon Azure up here as well. So I could deploy and work on this one as well here for the Win32 to have all of this up running for the service. But it would be nice if we could get the actual MMO server up and running as well too. That would be handy to do.
Yes.
Especially for the demo. So I'm going to go back to actually the server code here for the MMO, which they have an island, a Unity grid, Unity 3D client, and here is the server. So I'm going to load up the project real quick. And unfortunately, on the server, I can't load up. I don't have Visual Studio installed. I didn't pick that one. This is why picking a server with Visual Studio on it could be very handy when you're doing all of your debugging. I want to be able to debug this on the server on Azure, and right now I can't. I'd have to sit there and install Visual Studio, which I think at last count, the 2015 one was like a 4 gig download. So I don't think in the next few minutes we can do that. So I'm going to run that one locally instead here and run that source right out of Visual Studio. So I'll just do that from the deploy folder, from our source, the MMO, and we'll load that up. Apparently we do have 2015 in this. I don't know why it loaded up. Yeah, let's exit. I wanted to load this up with, open with, let's do our selector, and it came up with 15. I don't know why that came up with 15. So let's just open it directly from in here. I didn't even think we had 2015 installed on these machines. So apparently we must have somewhere.
Learn something after 8 hours of sitting here.
Absolutely. So we go through the source code. We're going to load up the project. Yes, we're upgrading. The original project must have been an older Visual Studio.
Yep.
And one error on the WinGrid world, but everything else looks like it came up nicely. Gotta love those analysis reports.
Yep.
So we won't be able to do the grid world, but that's okay.
Actually, it looked like it was just a Stalcop problem, so you might be able to do the grid world.
Yeah, we'll get one of the servers up and running. So here is our MMO demo server, and so I'm going to actually sit and I'm going to start that server up. And of course, it is missing the socket exe, so I need to copy that over to it. So I think that was the whole problem with the other one, is the fact that I need to copy over, and that actually does make sense in the deployment. It doesn't know if you're running a 32-bit or a 64-bit machine.
Sure.
So for you to copy all of the files here over to the MMO demo into its bin to be able to run. So we'll just skip the names that are the same, and then we should be able to run the socket server, which I'll just run it as server's already running. Let me shut that server down actually, because that default server was not this one that we have from this folder.
Mm-hmm.
And I'll even shut down the console or for the controller so that we can just launch it from inside of this folder locally. So let's go to the control. Yes. We're going to start as default here. And we should have, Photon is now stopped, it's saying. All right, it is running, and it stopped itself. Of course, I think we've been having that luck with all of our demos here today. No, not all of our demos. Some of the demos have, just a couple of them. Some of them have worked really well. And so I want to come here, and I'll go to my MMO debug folder here and skip the files that it's already doing. And we'll try starting that up again. Oh, that's why it was looking for the 32-bit deployment folder for the socket. And I was running 64. So, I mean, it's all about the pathing, where everything is, because it went up 2 folders and was looking for it at this level for everything in a 32-bit deployment folder. So I can copy the folders. Let's go back to my source code with this. Let's paste it in. Let's see if we can actually find it. I'm just not at the right level. There we go. I still can't figure out what level we're going to be at here.
So go into your project folder.
Yes.
So MMO. And then, yep. So into MMO, because you got to be in the bin folder for that one, right?
Well, it might be in this one that I...
No. Well, it could be. But if you go into bin, right. So now it's going to go up 2 directories and then down into deploy.
And then down into deploy inside of here.
Right.
So let's make this one here.
There we go.
And
move that in there. There you go. Try that.
Let's try this one. Still didn't like it.
Nope.
So we have this at one wrong level somewhere, but we'll, as I said, being able to run this kind of a demo and running your own server, if we look at the code that they came here for and looking at the server, we have things like looking at our peers. And it's just doing a socket server. It's doing all the different messaging back and forth. So this way we can look at the various properties, look at our MMO radar, looking at all the different things for doing the subscribing to the radar to get the information out. And these are all things you would have to build yourself for being able to do it. And there is a lot of things that are already built up with this and code for you. And so utilizing that, looking at a world cache, looking at the radar, looking at items in the world, being able to have it to where you can utilize all of these that are already made for you, looking at getting snapshots of items, getting positions of items, destroying them. Anything that you want to be able to do with the items in your game inside this MMO, here's the coordinates of our items. All of these things are things that you normally would have to do all the coding. Now, I was teaching college many, many moons ago, 15, 20 years ago, and we were doing some MMO type of design work at the college. And we were talking about being able to do it. So I purchased a server. I purchased my own copy of NT3.5. Yes, I'm dating myself, NT3.5. And so I still have that at my house. It's still in its cellophane to be able to run my own server and to be able to write the server and all the logic and all of these types of things that are already built into this demo in this world. And the thing is that by having a lot of these things done for you, you are able to work and concentrate on your core, the core logic of your game, the core what's differentiating you from someone else, and not worrying about something that you are not as competent with.
Sure.
So, I mean, it really does help with a lot of those things by utilizing someone else's code and not reinventing.
Yeah, no, for the project that I was working on a couple of years back, Plane Shift, before I joined, they did all of the plumbing work to develop the MMO and develop the server. And they were using C++, but it still took them about 2 years to go through and write all of the basic mechanics of doing the message passing and doing the message handling and getting it right with how they're going to architect the server with multi-threading and being able to sustain hundreds of clients, et cetera, and the amount of testing that they had to do, and just getting all of that stuff right takes a long time. So if you've got the ability just to plug in something that's going to work out of the box and get you up and running and get you working on your game mechanics, it might be a good idea just to take that path, get your game ready, get it up and running, and then use the time that now you've got something working and maybe even published to go back and say, okay, well, maybe now I want to go and develop my own server because, there's certain things that just I can't do, or I find it more difficult to do using some out-of-the-box software. So these ways, you can get something moving, get something going, and get your game forward, which is just going to be a lot easier from the developer perspective. That I'm going to be more engaged in my game and getting the game done because I'm making progress in the gameplay, as opposed to spending, possibly years developing server-side code.
Well, and the thing is that saves you so much time and effort, but there are some people that just love the whole idea of it wasn't invented here, it doesn't exist, it doesn't work right. And unfortunately, those people exist. And there is something to be said for that sometimes, but utilize the things that are there. Utilize a key strength. Michael's strength being X and A is one of them. If we're going to do an X and A game, let's utilize that strength instead of, we're going to put him on iOS apps instead.
Yeah, that'll take me a little longer.
Just a little, unless you're using something like MonoGame or something like that.
Sure.
But that's a whole different topic entirely, which I think there's even MVAs on those.
Sure.
So, there's a lot of these different things. So, overall, I just want to talk about some of the things that we've seen all today with some of the things overall with Azure. We were able to go to our websites in Azure and be able to create websites, to be able to create and as it's loading up all the different things for me, be able to go to my Azure, make a virtual machine very quickly, open up my sockets and my ports, and communicate back and forth with it. We were able to make websites with it. We were able to say, hey, we could produce storage with it. But as we mentioned earlier, Azure's changing all the time. So, Michael, do you think there could be other things we haven't talked about that really people could use in game making?
Oh, I'm sure there's things we haven't thought of yet that could be used. We barely touched on the machine learning aspect of it, and that's a huge thing, and that's going to become even bigger. And we don't know what the Azure team's going to come out with that they could actually, be useful in games too.
Right, and the thing is that most things are going to need a website. Most things are going to need if you're going to be doing an online server. Now, it could be that you're not doing an MMO. Maybe you're doing something like a Words with Friends type game. Well, that's still a server doing things for you in the background. You have the ability of doing lots of different parts to that. You don't have to be an MMO. You don't have to be a turn-based game like that. You could be to where you're doing something that's a really simple, the older-fashioned term might be like a play-by-mail type of game, to where it's, I did my turn, I'm sending you the information that I did my turn. But utilizing push notification, utilizing some of these key things that Azure does support and that we have is very valid. And while we were actually talking and while we were doing all of the things in the session, the Azure portal actually updated on me during the middle of this. As I said, they're doing changes on a very quick and routine basis, as fast as maybe 36 hours for some things. The Azure portal, I give talks weekly on Azure, and almost guaranteed during the middle of one of those sessions, the portal will update, and I have to refresh it in my browser. Not because I need to, but it will not stop me and let me do anything else until I refresh.
Small price to pay for new functionality, I think.
Absolutely, and so I'm trying to refresh the portal now to be able to get to ours, but for some reason I'm going to actually stop the browser and restart. I'll go to it back with Chrome. Okay, good. I wasn't playing Age of Ascent. You can't blame me for that. I didn't go to there. All right. Now, you can also set up multiple accounts that have access to your Azure account. Multiple people and multiple logons. The main login that I have actually has 4 or 5 accounts tied to it. So this way you could utilize one account name, one logon to be able to do it. I do find that the new portal in Azure does have some nice features. You can't do everything in it. You can't do everything in the old portal. It's kind of a mix and match. You have to kind of know what's what in each of them. But it looks like the portal is up and running now. So we have our servers, including our Minecraft server that we had up and running all day. We forgot to play Minecraft.
Well, we did. We're having too much fun with Age of Ascent.
That's true. And sitting and watching us do a video just playing Minecraft might not be as fun as everyone playing.
Not unless we were wearing HoloLenses. That might have been more interesting.
That would have been a very interesting thing with the HoloLens for doing that in 3D. But then not everyone that's watching could actually be watching it in 3D as well.
Yeah, been strange. We would have had fun.
We would have had lots of fun. When do we not have fun with these things?
Seriously.
So the Azure portal, and the nice thing is I actually see here on the Azure portal there is a outage. So that might have been why we were having a small issue earlier with a few things. The Hadoop Insight is having a small issue right now. But it's nice to be able to look at a part or a component of Azure and look at, yep, Active Directory is perfectly fine. Our content delivery network is perfectly fine. Cloud services are fine. And to be able to have a map to show where in the world it is having issues. So there are some really nice things in the portal. There are some nice things that we have in Azure. But there are things that, like I said, we haven't talked about, like the media services and streaming, the content delivery network. That actually was renewed fairly recently with a system to where all you have to do is point it at a blob storage or website and say, that's in my content delivery network. And then if someone is coming into it from somewhere else remotely around the world, it'll get copied local to them first somewhere in the Azure network. And then all their requests will be going to that local repository instead of to the one that could be halfway around the world for you.
Right, which would make it a great usage for delivering, some of your static assets like, graphics and things like that you need delivered to your game rapidly, and you don't want to, or you're updating them as an update in your game or as, part of some dynamic content. You can put it out onto the CDN, update the links and maybe a dictionary of a file that has all the locations to them and pull them down from the CDN instead of spending a whole bunch of time, streaming it from, a web service or something like that.
And even in Azure, in the marketplace, there are constantly adding, there's over 3,000 different things in the marketplace now for Azure. And things from identity and authorization that Michael talked about, being able to do the multi-factor authentication, to data storage, whether or data services like using the Bing Search API or Redis Cloud or Redis Cache. Redis Cloud would be a service that Redis Labs is hosting it for you instead of doing it up in Azure, or you're doing it on your own account in Azure. But the notification hubs, Pusher, SendGrid for emailing, we have services for doing a lot of these things, and even developer services to be able to do insights and tracing and logging, log managers and doing dynamics on things. Tracing out all of these things to understand where there is a bug, where there is a fault. Did my data get up to the server? Did it not get up to the server? Knowing that can really help you, especially when you're doing remote things up to any kind of a server, a virtual server, whether it's in the next room or whether it's on the Azure data centers. I remote desktop or SSH over to any of them, and I don't care where it is really, but I need to be able to look at all those logs and collect all that stuff. And the other thing which is nice is the fact that now you noticed when I searched earlier for Minecraft in the marketplace, I wasn't actually anticipating any because I only knew of one that was in the VM depot. And now it looks like everything is getting pulled into the marketplace directly, including the one that Microsoft just made for Minecraft.
Sure.
That was, I had not seen that even last week. So we keep adding new things, we keep adding features and all that. Any other features do you think that would be good for gaming, Michael?
You know, I've been thinking about it, and I actually haven't come up with it. I think we touched on most of them that I've been able to think of to be able to leverage in gaming. Although, you know, I might just be short-sighted right now. It's been a long day.
It has been a long day, but we did get a chance to play an awesome game.
We did?
And we did get a chance to, to live change our demos to be able to do all these kinds of things and do the communication. So we will be putting up all of the demos and source code as a GitHub repository for everyone, including some extra ones as well. Now, I'm not sure which repository we're going to put that in yet.
Nah, but we'll put the link up.
We'll make sure we get the link to go along with everything as well. And I think it was a pleasure having everyone join our session today and to have it to where they could do it. Now, I know we may not have gone into as much detail in some subjects that some people may have wanted, but we are limited. Again, I taught this as a full semester-long course. So there was no way I could do a semester of material in the 8 hours we had here.
Yeah, so, you know, it's a real pleasure having everybody join us and be able to, you know, disseminate some information to you. We also want to make sure that you fill out the survey and give us some feedback. Let us know how this went. We really appreciate it, and it helps us out a lot in being able to deliver great content for you.
All right, well, thanks a lot for joining us.
Thanks, Steve.
Thanks, Michael.
We'll see you again later.
Okay.